We are back. Headphones, AirPods not available. Why aren't the AirPods not available? Testing. The AirPods are very available. Howdy, howdy. We are all lit for lamp on this blessed day. Couldn't connect. Trying to reconnect. Okay, we should be good. Will there be Ask a Physicist tomorrow? Tomorrow's Friday, right? We don't do Ask a Physicist on Friday. We do that on Tuesday and Wednesday. All right, what's today? Today's the 2nd. All right, so we'll jot some stuff down. Are you going to talk about the Artemis mission with Flatties? Possibly, yeah. All right, we have some super chats. Let's go over those. So from Dr. Carla, good to see you, friend. Welcome back, Dr. Blitz. We missed you. Well, I missed you guys too. It was kind of a miserable. The last week and a half has been kind of miserable, but we're not 100%, but we're getting there. From James Pash with the $2, is this cancer-free Blitz for reals? Not only is it cancer-free, it turns out it was never actually cancer, to the surprise of everybody. From Unfornicated with the $5, are FLERFS going to really show after the Artemis launch? Can't wait to hear the copium-induced excuses. Oh, they'll just say it's fake. Of course they will. Of course they're just going to say it's fake. Right? Yeah, also my nose is... It's getting better. It's not as bad as it was a few days ago. Recovery sucks. I still have a tube attached to me. You can't see it because it's hidden under my shirt, but I still have a tube attached to me, hoping to get it out soon. And I still have some pain, but we're okay. James Pesh, thank you for the $1. Is pee stored in the tube? No, actually, it's like a blood drainage tube. So they took out a big bunch of stuff, like a bunch of stuff. And so then because they're worried, like there's risk of it like filling up with fluid and blood and stuff, they have to attach a tube to make sure that it, you know, doesn't fill up with stuff. Although it's not really draining anymore, so it is true. Pee is stored in the balls. You heard it here first, folks. All right, let's talk to Liam. It's been a while since I've done this. Do I even remember how? Liam left. Okay. We'll give it a few minutes. Yesterday, you should have made a live stream advocating for Flat Earth. Well, I was going to, but I had an early, like I was feeling okay yesterday too, but I had an early appointment with my surgeon to check some things out because there was some worrying stuff going on with the drainage tube. And so I missed my normal live stream window. And by the time I got back, it was like an hour away from the rocket launch. And I was like, why would I do a live stream when I could just watch the rocket launch? So I decided to do that instead. From Von Doodle with the 5 pounds, we heart you, Dr. Blitz. Well, I heart you guys too. And for Mr. Payco with the $20, I know this is the real Blitz because he's the same shape as the other Blitz. You and Ian have taught me so much. I'm so confused. What other Blitz? I feel like there's a reference here that I'm missing. And from James Pesh, how can we help with support? Don't worry about it. We're doing okay. All right, let's bring up Saint.
Hello.
All right, let's bring up Saint. Saint, for some reason I can hear myself in your audio. So, can you try to fix that? For some reason I can hear myself in your audio. So, okay. Well, he left. Let's try him again.
Is this better?
It is, but for some reason your audio is like super, super loud. Maybe it's just me. Give me some test audio.
Hello.
Okay, maybe it's just on my end. That's fine. So, Saint, what shape do you think the Earth is?
It's a circle, my friend.
It's a circle. Okay. So, like the shape of a basketball, or oh, so like the shape of a dinner plate.
Yes.
Okay. Why do you think so?
Because of the amount of research I put into this. I've done tests. I've done many research with my friend. We do experiments like nearly weekly on this.
Okay. What experiments have you done? If you don't mind me asking.
We do stuff with ChatGPT. We put sticks in the ground and we watch the shadows.
Okay. And then what happened?
We didn't notice any difference.
Any difference between what?
Where the shadow was when we started and where it was when it ended.
So you're telling me that at like 9 o'clock in the morning, the shadow was in the same direction as like at 4 o'clock in the afternoon?
No, and maybe it's just where I live, but I don't know. That's just
so what did you what did you observe? What was the experimental setup?
To see if the shadow would change, showing the sun.
If the shadow would change in what way?
The positioning.
So, like over the course of a single day, or over the course of a year, or what?
The course of a day, like a few hours.
So when you made these measurements, are you telling me that the position of the shadow didn't change over the course of a day?
Not that I could see.
So you're telling me that when the sun was in the east, the shadow was pointing in the same direction as when the sun was in the west?
Well, that's what it appeared.
Really? So isn't the shadow supposed to be in the opposite direction from the sun?
Yes, sir.
Okay. So are you telling me that during your experiments, the shadow was not in the opposite direction from the sun, at least for part of the day?
Not when I was looking at it. Maybe I messed it up.
I think you may have messed it up, yeah.
Because how do we know it's a sphere? Like,
I mean, every time I've ever looked at shadows, the shadows are always in the opposite direction from the sun. And it sounds like you're coming on and telling me, oh, but when I looked at the shadow this one time, the shadow wasn't in the opposite direction from the sun. It's a little bit suspicious.
But then how come we have all like the stories about the Earth being flat and all these ancient people saying this?
We also have stories about like dragons, and we have stories about like men who can throw lightning. That doesn't mean that it's real.
Well, maybe we should, like, there could just be stuff outside our world, like, I don't know, like if it is flat, like different walls.
I thought the reason that you believed the Earth was shaped like a dinner plate was because of experiments, not because of stories.
I do, but I also like the stories.
So why did we change off the topic from the experiments?
Oh, we can go back to that. I was just saying.
I'm just really struggling to understand what experiments you did. Like you just stuck a stick in the ground and then you just watched the direction that the shadows were pointing in?
Yes, because
And what was your observation? Like be detailed here. What was your observation? So like how long did you wait?
I would say I waited like 2 hours. So I went outside, I took a stick and I just stuck it in the ground.
Uh-huh.
And then I put dirt around it so it wouldn't move.
Yep.
And I took a picture of the shadow.
Mm-hmm.
And it was pointing straight, like, so, well, obviously, but I don't know how to explain where it was pointing.
Well, you could use words like north, east, southwest, northwest, southeast. Those are good words.
Yeah, but we don't have a compass.
So then how did you take measurements?
I didn't measure the shadow.
It doesn't sound like you did an experiment at all. It sounds like you just stuck a stick in the ground and then stared at it.
Well, what is an experiment?
An experiment involves data collection.
I collected data.
What data did you collect?
The position of the shadow.
Okay, but you didn't actually collect any data about the position of the shadow. That's kind of what you just said.
So, like, do you mean I should have took a picture?
Well, pictures would be good, but better than that would be like, what direction was it pointing in? Give me like you know how how like north is 0 degrees and east is 90 degrees and south is 180 degrees. Like you should be able to give me like an angle because you would take measurements.
I didn't have a compass, but I guess we could just say it was probably, well, it was pointing towards the back, so I guess east.
Okay, so in the morning it was pointing east?
Yes.
So what direction was the sun in?
The opposite.
So you're telling me that the sun was in the west in the morning?
Yes.
You're telling me that the sun rose in the west?
Yes, where I live.
Okay. Do you happen to live on Venus?
No, sir.
Okay. Then it just seems like you're lying to me.
Why? Do you want me to say where I live?
Yeah, sure. Just give me a general location.
Europe.
Okay, so in Europe, the sun rises in the east.
I'm not in this one country.
What?
There's one country where it doesn't.
No, there's not. The sun rises in the east everywhere on Earth.
How, though? How do we know that?
This is like something that you learn in 2nd grade. And for what it's worth, I've lived in Europe for several years, and the sun rises in the east.
Is east even real, or is that a concept?
East is a direction.
But do we create that direction?
It's just a direction.
But is the direction real?
I'm too old for this shit.
Sorry about that. You don't look that old, though. You look pretty good, sir.
Well, I appreciate that. But, like, you know what east is, right?
Yes, sir.
Okay. You know what north is?
Yes. Northeast, southwest.
Right. So if you're facing north,
yep.
Which direction is east? It's left or right?
It's right.
Okay. So you do know what east is. And you're saying that it was west. The sun was rising in the west.
That's my mistake.
Yep. Yeah, it is.
Sorry about that.
So which direction was the sun in?
The west.
The sun was in the west, so the sun was rising in the west.
Yes.
So if you were facing north, the sun would have been on your left.
Yes.
At like 9 in the morning.
It wasn't 9, though.
Well, you know, in the morning time.
Oh, yeah. Does the time matter, like you think?
Well, yeah. Because I think you're lying to me. I think you're actually trolling.
Bye.
Bye. Sure. We have delivery. Just bloop her down. We have delivery of a cat. Oh, she doesn't want to be up here. She really doesn't want to be up here. All right, we have some super chats to read, and then we'll bring up our next guest. From DeBizzle with the $10. Happy to hear it wasn't so severe. Wishing speedy recovery. Oh, I mean, the surgery was pretty rough. It was about as good as it could have been, but it was still pretty rough. But I appreciate it. We'll hope for the speedy recovery indeed. From Gravity Hits Hard with the $5 Australian. I'm glad you're back. Me too. Was I ever really gone? Yes, obviously. From Orion Cooper with the $2. Nice to see most of you back. Yeah, so I did lose like a chunk of me, but it wasn't a fun chunk, so. From Mr. Peiko with the $20. I was referring to the goober who thought the pyramids were built by giants because same shape equals same thing. Oh yeah. That guy was so funny. Here's a square. Here's another square. Must be the same thing. And then from Adam Hurst with the $20. Glad to have heard the good news. Congratulations. Thank you. I appreciate it. Yeah, no, the news is quite good. Still going to be a painful recovery, but we'll get there. All right, let us bring up our next guest. Let's talk to Rapid Recycling Scotland. This guy's probably an experimentalist. Rapid Recycling, have we spoken before?
Never.
Okay. Rapid Recycling, what shape do you think the Earth is?
I think it's flat.
Okay.
Sure.
Want to tell me why?
Just my perception tells me that, and also because there's no proof to show that it isn't flat.
So you think that there's no proof to show that it isn't flat, and your perception says that it is flat? Okay.
Yes. Yeah.
So
certainly.
what do you take to be proof?
Well, proof is, like I say, you look up, you see the projector of rockets. They didn't go straight up. They always curve.
Why would the rockets go straight up?
So that they could leave the atmosphere quicker.
That's not the goal.
What is the goal then?
The goal is to enter orbit as efficiently as possible.
What about re-entry as well?
What about it?
Well, what, they come in at the same angle? Or do they
Not
come in
necessarily. It just depends on how they engineer the system.
Well, I think there is a lot of debate about it, and like I say,
there is no debate. If you're talking about like orbital mechanics, there is no debate about it. This is very straightforward science.
Well, Eric Dubay hasn't been debunked, has he?
I've never spoken with Eric Dubay, but I don't think anybody really takes him seriously anymore.
Well, I think he seems an intelligent man. I have watched his
Are you sure? So did you know that he is, so I believe it was Eric Dubay who said that, and this was like 2 years ago or something like this. I believe it was Eric Dubay who said that if you could go to Antarctica, you would not see a 24-hour sun. I believe he said that, and I believe in fact that there are clips of him saying that, and I can pull up clips of him saying that if you're interested.
Okay, and that's been debunked, has it?
Yeah.
Yeah.
A bunch of a few flat earthers and a few globe earthers went to Antarctica together on a private expedition, and they recorded a 24-hour sun.
Like, what about the distance when they take the Nikon P900? Is it the camera?
Oh, I'm sorry, that was not Eric Dubay. That was David Weiss.
Was it David Weiss that done that? But Eric Dubay supports that theory as well. Yeah.
I would imagine so. Yeah. At least he did before he changed his mind when the flat earthers actually went to Antarctica and saw a 24-hour sun.
Okay, but what about the distance that a P900 camera can take? It sort of debunks that the ship is falling below the horizon.
Not really. How does it do that?
Does it not?
I mean, I've never seen a P900 zoom in a cruise ship that's gone that's halfway obstructed.
Well, I've seen it sort of zoom in to like over distances that sort of contradict the curvature of the Earth.
Okay. Do you want to show me the video that you're talking about?
The video, I can bring it up and come back to your channel later on with it once I find it, yeah? But
yeah, sure.
There's multiple videos like that.
So here's what I would suggest. Make sure that you find a video that has that when you can see the cruise ship, it should be a cruise ship because cruise ships are very, very big ships.
Yeah.
When you can see the cruise ship, like even though it's, it might be small because it's far away, you should only be able to see the bottom half of it, or sorry, the top half of it. And then you should see them zoom in, and you should now see all of it, not just the top half. Okay?
That's
if you can find a video
Yeah.
of that, then you'll have a very compelling case.
Okay, and if I take it you've searched for that video and you can't find it.
Then it doesn't exist.
Okay, what about why can the stars not be seen then? When NASA shows you footage or any space agency shows you footage, there are no stars in the background.
So, I mean, it just depends on which footage we're talking about. If you have footage,
any space footage of.
If you have space footage that includes either the sun or the moon or the Earth, then you're not going to be able to see it because those three things are all very, very bright. And I imagine you know how exposure on a camera works. If you have something that's very, very bright, you have to reduce your exposure, which prevents you from seeing dim things. However, there are plenty of pictures, plenty of videos of the night sky where you can see stars because there is no sun, moon, or Earth in the frame. Now,
from space.
Yeah, from space. This is what space telescopes do. Now, look, the point is you've brought up a lot of questions. It sounds like these are not questions that you've looked for the answers for, because these are all like super easily Googleable questions, and you can find the answers to all of them.
Yeah, I have Googled it. I've had many arguments with friends and everything over it.
But
Like I say, I'm
but then why are you
100%, I'm not 100% sure.
why are you asking the question if you already knew the answer?
What question?
Questions like, why can't you see the stars in the pictures of the Earth?
Because that's what I'm saying. That is suspicious. Because you should be able to see this.
It's not suspicious. So look, everything seems suspicious if you don't know how anything works, right?
Yeah, correct.
But
yeah,
you don't. But you don't know how it works. If you just looked it up, you would know how it works, and then it wouldn't be suspicious anymore.
Yeah, but I know. But I can take pictures of the night sky with my telephone.
Not
And that, you know,
so you sure can, but not if the moon is in frame, unless you have dynamic exposure settings, which some modern phones do.
yeah, and that's what I'm saying. Modern phones have that. So why doesn't the space agency's cameras have that?
Because then, so you know that dynamic exposure is a type of computer processing.
Yeah.
And flat earthers complain whenever there's any sort of computer processing done on a photograph.
Mm-hmm,
so why would they do more computer processing to try to make the flat earthers happy?
Well, because, like I say, because to bunk us, obviously.
But you wouldn't believe it because you'd say, oh, they're just doing computer processing.
Well, we'd be able to prove it in coordination with the stars. Obviously, we could check the coordinates.
So the official pictures that you can find from like NASA or the European Space Agency or the Japanese Space Agency, all these things, they have pictures of the night sky with stars in them.
But not from space.
Sure, they do. That's what the telescopes do. Yeah, like the Hubble Space Telescope. Yeah.
Well, I'm looking down at Earth.
Why would you see stars if you're looking at Earth?
So the space, you're sorry.
They don't have dynamic resolution, or they don't have dynamic exposure.
Okay, then that's just one question anyway, and that is suspicious.
But
they didn't have dynamic exposure.
It's only suspicious if you don't understand how it works.
Yeah, no, but the most highly funded space agency in the world is NASA. I mean, surely could
dynamic exposure isn't a good thing for getting accurate photos.
Well, I don't know. Like I say, they could take pictures. I can't see any reason why they can't pick up the stars on their cameras.
Right. Then the photographs wouldn't be an accurate representation of the brightness of the things that you're visualizing.
I mean, I understand what you're saying, but if I shine a picture, the camera right at the sun, I understand. Yeah, that it's got to be clear.
Yeah, I mean, the Earth is quite bright as well. The Earth is quite bright as well.
The Earth is bright as well. Yes.
Yeah. So it's not glare, but it is an exposure issue. Surely you've taken a picture with your phone where you've overexposed something, right?
Yes.
Okay. Yeah. So if you wanted to pick up the stars while the Earth is in frame from space, say, then you would have to overexpose the Earth.
Well, like I say, I'm not an expert on photography, but what I am an expert on, well, not an expert, but I mean, you can't have a fire without oxygen.
The sun isn't on fire.
No, I'm talking about the rockets that are supposedly flying through space.
The rockets bring the oxygen with them.
They bring the oxygen with them?
Yeah, they have liquid oxygen. Or sometimes they use solid rockets. Yeah, you can.
You can light it in a vacuum?
Yeah, sure.
Can you? I've never seen an experiment showing that.
Just look for like firing a gun in a vacuum chamber. You'll find it. Okay,
I'll look for that. The other one is obviously the major red flag is, and this is where you have trouble here explaining this.
Yep, sure I will.
How can it bend around the planet? I mean, it is ridiculous, that concept. That
which part's ridiculous?
That it can bend around a sphere.
Why is that ridiculous?
Well, what holds it there?
Gravity.
No. Water finds its own level. You can't bend it. There is no experiment, and this is where we've got to differ. There is no experiment on this planet that shows a sphere with water on top of the surface spinning.
There's a guy on TikTok who did that exact experiment. He did it with a rubber ball.
A rubber ball, and he kept water stuck to it.
Yeah.
Yeah, I've never seen that. I'll have to look that one up.
Want me to show it to you? I can show it to you right
please. Now. Yeah, excellent.
Yeah, let me pull it up.
So how does it contradict it? Because I've spun a wet ball, I threw a wet ball, and the water comes off it.
And hold on, just to be clear, did it stay wet?
Yeah, it stayed wet.
Okay, then that means that hold on, then that means that water stuck to it. That's what it means to be wet.
That's because it was a furry ball. That was a tennis ball.
Okay,
if it was a plastic ball, then it wouldn't stay on it.
I think that this ball is rubber, or it's like some sort of it's like a handball kind of thing.
Okay, that's a great. That flickering looks suspect, man.
That's a fan. But I'll skip over to the relevant part. One sec.
Okay.
So here he's going to take the ball. He's putting it in a cup of water. He's going to pull the ball out of the water. He's shaking it off a little bit. Clearly it's wet. Clearly it's spinning. It's even going to slow down in a minute, and you can see that it's going to spin. Here's another angle. It's still wet.
Yeah, wet. It's not got oceans on it.
What do you think? Sorry, what do you think wet means?
Yeah, wet is wet. That's because it's stuck to the material of the ball.
What does wet mean?
Wet means water. It's
covered in water?
Yeah, it's covered in water, yeah. But there's no depth.
Oh no, look. Wait a minute, there's no depth? So you're saying that has a depth of 0?
There's not a lot of water there. There's not a lot of water there. That's a wet. That's a different. I mean, if I shake a wet towel, it's not going to dry right there, is it?
So interestingly enough, in that video, he measures the depth of the water. And the depth of the water, so obviously this was like the size of a tennis ball, right?
Relative to the Earth.
Relative to the Earth, the water, there was more water on that ball than there is water on the Earth.
Yeah, I disagree with that. But like I say,
he measured it. Like, you can just measure the depth. The depth of the water was about 0.5 millimeter on that ball. Like, you can just put a ruler on it and you'll measure like 0.5 millimeter thick layer of water all around it. And
we didn't know what the sorry for interrupting. We didn't know what the surface of that ball was made of.
It's made of rubber. It's made of rubber. It's made of rubber.
Rubber.
Yeah.
Yeah, a rubber ball. I mean, it would stay wet. Yeah, but it's
that's an example.
A couple of spoonfuls. Could you put a spoonful of water on it and keep it there? If there was a wee hole in it, an indentation.
Hold on. That wasn't the claim. The claim that you made is that you can't produce an experiment. You can't reproduce water sticking to a spinning ball. And I just showed you that you can.
Well, that's answered my argument. It's even compelled it. It's made me more leaning towards a flat Earth. If that is it.
So
because
hold on. I gave you an explicit counterexample for the claim that you said didn't exist. I showed you an example of something that did exist. It was exactly what you asked for. And now you're saying that you believe the flat Earth more because I showed you a counterexample of the thing that you said didn't exist.
It never had any amount of water that we could really compare. I mean, a body of water. I'm talking about a wet surface.
Okay, so do you understand how thick the oceans are relative to the size of the surface, relative to the size of the Earth?
Well, from ground level, yeah, they go way deeper than that. Yeah.
No, they really don't. The depth of the ocean is the depth of the ocean maxes out at like 7 miles, which is like 10 or 11 kilometers, and that is less. That is less than 1% the width of the Earth.
But that's below ground level, though.
Yeah.
Yeah. That's what I'm saying. So if that rubber ball,
that's why wait a minute, hold on. That's why there were continents stuck to the rubber ball.
I've seen the continents.
See the continents?
Yeah, but the water doesn't reach to the top of the continents, does it?
So do you know how? So relative to the size of the ball, do you know how big those continents would be? Like what their elevation would be above sea level?
I do not know.
Okay, they would be hundreds of miles above sea level.
Yeah.
The continents are much thicker than the continents actually are in the real world.
If those blue areas on that rubber ball had an indentation the size of a teaspoon, and the water stuck in there, then I could not argue with you any longer.
Why would you wait? But then that's not to scale.
That is the scale because you've got the Ariander. What's it called? The Ariander hole or something? The big massive hole.
I have no idea what you're talking about. The Mariana Trench is the deepest part of the ocean, and it is 11 kilometers deep. And so if we rescale down the Earth, so let's rescale the Earth down to be, 3 centimeters across. Let's say 4 centimeters, just to be generous. We have to let me just do a quick calculation. So we're going to rescale the Earth. The Earth is so we want it to be how big is this? This is like. That's like 2 inches, or is that like, yeah, let's say 4 centimeters across, just to be on the safe side. Maybe 5. So the Earth's actual radius is like 6,700 kilometers. And so we have to multiply that by 2 to get the diameter, and then we multiply it by 1,000 to get meters, then we multiply it by 100 to get centimeters. So the Earth's actual diameter is like 1.3 billion centimeters across. Now we want to divide that by 4 centimeters, right? So this is our sense of scale. So the diameter, the rubber ball is about 335 billion times smaller than the Earth. Now, let's take 11 kilometers, 11,000 meters, say, and divide it by 335 million to get how deep the Mariana Trench should be on that ball. We get, so this is in meters.
Mils and meters.
So it's 11,000 meters divided by 335 million. We get 3.2 times 10 to the minus fifth. Now we can multiply that by 1,000 to get it into millimeters. So it is 0.03 millimeters deep is how deep the Mariana Trench would be on that ball. Which is actually less deep than the depth of the water was on that ball. The depth of the water on that ball is about 0.5 millimeters rather than 0.03 millimeters. So this is to say, you're just having a failure to understand scale here. The Earth is so much larger than the ball that even though the ball has a very, very thin layer of water surrounding it, that thin layer of water, once scaled up to the size of the Earth, would have oceans that are 100 or 10 times deeper than our deepest part of the ocean.
I disagree, mate. Like I say,
which part? The math checks out.
Well, like I say, I've not got the maths in front of me. I've never been great at maths, that's for sure. But I certainly know a body of water cannot sit on a ball. Like I say, it cannot grab it.
I mean, you say that, but like
inertia will spin
according
it
to
right
who?
Off, mate.
According to who?
According to reality, there is no scientific. If that's the, I mean,
it's just not true. There's just no law of physics that says that.
Mate, if that ball kept spinning there for any length of time, that water would not remain there. That's what I'm saying.
Why not?
The water would not remain there.
Why not?
For any length of time.
Why not?
Because it wouldn't. It would dry up in seconds.
Why would it dry up?
Because the tiny little particles would keep moving off it as you're spinning it. Just like when you spin a bucket, the water stays in it because it can't escape. That's the only reason why the water stays in the bucket when you spin it round.
So you realize that like water does evaporate from the ocean and lakes.
Yeah,
that's what you're talking about. And then it rains. So why would that drying up water disappear?
Well, there's another part of this, the test that's never been done. Why can't?
Of course we're pivoting. Look, why don't we stick on one thing?
Well,
like which part is confusing? Which part is impossible? Like gravity keeps the water in.
Because, like I say,
gravity keeps you and me stuck.
Got to keep leaving it.
Why would spinning it make the water leave it?
Because that's what inertia is. Inertia does that.
That's not what inertia is. No. If you want to calculate where or what the water will do, you have to do a computation, right? And so what you'll on the one hand, you'll have gravity pulling it down. On the other hand, you'll have the centrifugal force pushing it up. And you can compare the size of those two forces. And the gravitational force is about 100 times bigger than the centrifugal force. So the centrifugal force that's trying to fling it out is just not strong enough. The gravity is about 100 times stronger.
I think gravity is misconceived.
Okay, can you explain why things fall?
Weight.
What is
density and weight?
What is it?
Weight.
What is the cause of that force?
Mass.
Okay, so you believe in gravity because gravity is the force caused by mass.
I don't know. I disagree with it. I disagree with it.
Which part? Which part do you disagree with?
With gravity, if it's sucking it down, but it can't suck it. Like I say, a feather can float away in the air, or dust can float.
Yeah, there can be more than one force, and sometimes one force is bigger than another, and so whichever force is biggest wins.
Yeah,
I don't know what's so hard to understand about that. I mean, like, surely you have intuition for this, right?
Yeah,
surely you agree. I mean, surely you agree if you have two magnets, each one trying to pull, say, like an iron sphere, whichever magnet is stronger is going to win, even though there's two forces pulling in opposite directions. Whichever one has the stronger force will win. This is not rocket science.
It's the weight of things. I believe that's what I believe anyway. That it's the weight of stuff that
and weight is caused by gravity.
But what creates gravity then?
Mass.
Mass doesn't create gravity. Mass is just weight.
No, mass isn't weight. Mass is the amount of stuff. Weight is a force.
Yeah, mass. But obviously, the more mass is anything, is the more weight.
So weight is a force, right?
Dependent on mass.
Yeah, it depends on mass.
Yeah,
and
exactly.
the reason the force depends on mass is because the force is the gravitational force.
Mm-hmm. You've not got the video where the guy shoots. Sorry for like I say, we're not going to agree on that topic. But have you got the video where the guy shoots a gun in a vacuum?
I can go find it for you. That was your homework to do, but I can go find it if you want.
Good. Yeah, it's just I'm not familiar with really doing multiple tasks on this at once. I mean, it's a debate. It's definitely still strong. I don't think the debate is dead. There's no been debunked.
I mean, it is dead. The only people who believe that the Earth is flat are people who are not educated on the subject.
Well, like I say, there's not just one or two people, mate. And we've done extensive research.
There's a lot of people who are not educated on the subject. I agree. That doesn't make them any less educated, or that doesn't make them any more educated on the subject.
I think it's still an open debate because there's no proof conclusively. Like I say, we can
do
debate all day.
Do you think that there are any physicists who think that the Earth is flat?
But physicists are controlled by the narrative, aren't they? I mean,
sorry, who are physicists controlled by?
They're controlled by the universities that they went to.
Oh, no, that's not how that works. Physicists are not. Physicists. I mean, wait, no, that's just not how that works. Physicists go to one university to get their education, and then they go to work at somewhere else. So why would they still be controlled by the university that they're controlled by
what they're taught at the university? I mean, no one's got to go against the narrative, are they? And say
no, that's not how that works.
How many physicists? What? Come on.
How many physicists do you know?
I know a few.
Can you name them? Are they like personal friends or?
They're not famous. They're not world.
Okay, well now you know one more now.
Okay.
And so here I am telling you that if you could prove that the Earth is flat, you'd win a Nobel Prize. Here, by the way, I found a video of firing a gun in a vacuum chamber.
Excellent. Thanks for that. Like I say, in the olden days, we used to sit down. People would discover things by sitting in front of a candle.
Here we go. Pulling the trigger, and fire. And it goes.
That's in a vacuum, is it?
Yeah. They show you the vacuum gauge earlier. See, there's a vacuum gauge over here.
How is that possible then? If you can't have combustion in a vacuum?
Because
it requires oxygen.
Let me explain. So,
thank you.
When you have an explosive, which is what gunpowder is, they have their own oxidizer built in. The gunpowder, has its own oxidizer. So it doesn't need to have gaseous oxygen in order for something to burn. The oxygen is already present in the gunpowder.
Okay, well, thanks for answering that. That's a good point. So it's a chemical combustion, yeah? Is that right? Safe to say?
Yes, all combustion is chemical. But look, my point is you'll find that there are no physicists who are flat earthers, and you'll also find that physicists, if you're working in research, that is, or if you're not working for a national lab, if you're not working for the military or something, you'll find that working at a university, you basically have free reign to do whatever research you want to do.
Yeah, I know, but you can't be a free thinker. Come on, you can't go against the narrative, man. Or you'll be poo-pooed. You know that yourself.
What evidence do you have? What evidence do you have to suggest that that's the case? Because just from as someone who is published in this field, as someone who has published things that go against the narrative,
have you?
Yeah.
Well, if you think you wouldn't be.
I submitted a paper for publication like 6 months ago that makes the claim that the universe won't continue to expand forever. That's against the narrative.
Okay,
I'm not in. Nobody's come after me. Nobody's mad at me for that. If it's good science, it's good science.
Yeah, that makes sense. I mean, if that's the case, if you're allowed to be a free thinker in this world, then how come we didn't have free energy then?
Because because there's no such thing as free energy, right? Like it's just not a real thing.
No, it's not. What you're saying that perpetual motion's impossible, yeah?
Yeah.
Yeah, I believe that because it's not been proven yet. But what I'm saying, free energy can be, it has been.
Well, okay, it depends. It depends on what you mean by free energy. If you mean by energy that we don't have to pay for, well, that's going to be trouble because you have to pay for infrastructure. You have to pay for the wiring that transports the electricity. You have to pay for all of these things. If you mean free energy in the sense of in the physics sense where you get energy from nothing, well, that's impossible, right? That's made up.
Yes,
it's not real.
Impossible. But what I'm saying is, obviously it's a con that we're still being fed all these fossil fuels and that they're relying heavily on. They could come up with cleaner energy in this day and age.
Well, yeah, we could. You should
in a control system.
You should blame the fossil fuel companies for that. It doesn't have anything to do with the scientists. The scientists are working on projects that, and in fact, modern optimized solar panels are 40% efficient, which is extraordinarily good. The
Okay, well,
question
you're a
is how do you
physicist,
actually
right?
how do you actually get them to production? That's the troublesome part, and that requires money. But
you're a
that doesn't have
physicist,
anything to
if
do
you-
with the science that's being done. But look. Before we derail, it should bother you that like there are no professional scientists who are also flat earthers, right?
Well, like I said, that's what I'm saying. I don't believe that they would be allowed to become scientists with a radical. Like, I mean, you're a physicist. If you invented,
Who stops you from becoming a scientist?
what I'm saying is, you're not allowed to get published, and you're not allowed to change the narrative. Is what I'm saying, because it's a well-protected narrative.
On what grounds do you have to believe that that's the case?
Well, I know it's the case because people invented energy from water and stuff, and they've been, you know what I mean? They've been silenced ultimately.
Oh, can you give me an example?
Well, I can't give you an example right now off the cuff, but I certainly will
How do
go
you know
back
it happened?
Yeah, again, I'll have an armory of evidence to show you. But I'm saying you're a physicist, and you
I've
know
heard
now.
lots of claims of these. I've heard lots of claims of this, but unfortunately, when tested, when critically examined by impartial observers, the tests don't stand up to scrutiny.
Well, you're a physicist, and you know if you come up with free, if you could turn water into energy, if you come up with that formula tomorrow, do you think you'd be allowed to run with it in this world?
Not only would I be allowed to run with it, I'd win a Nobel Prize tomorrow.
Wow, that's naive.
If I could prove it, look, I know more about this stuff. I know more about the community than you do. Why do you think that you know more about this than I do?
Well, because it's already been done. There's multiple examples.
Okay,
Of
so
guys
then
that have
what?
invented it.
So where's the examples of those tests or those experiments standing up to impartial scrutiny?
Well, like I say, I've seen them. I've seen documentaries, full documentaries.
Documentaries. So documentaries are not impartial, especially if they're not made by the people who are trying to promote a view.
I understand that there's room to manipulate them.
So if you want to prove a point, what you need to do is you need to let other scientists test your claim, and this usually goes one of two ways. Either someone genuinely thinks that they've discovered something novel, but then so they let scientists come in, and then the other scientists, external scientists, they're like, oh, you forgot to account for this. That's where the energy is coming from. It's not free, blah, 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 blah. And then the claim is debunked. Or they don't let external scientists come in because they know that they're being a fraud.
Yeah, and like I say, I'm not really, I can't say that I know either way for sure. I'm just telling you what.
You're talking awfully confidently about things that you don't know about.
Yeah, but I think I do have a perception, like most people do. You know what I mean? And like I say, you may consider it flawed. And at the end of the day, you can argue with science. Science doesn't answer everything. I do believe in a creator. You know what I mean? And that's evident. I mean, a lot of scientists, and they believe that we're created. Anybody that
it's true.
It's true. You just believe we come from nothing.
No, that's not the claim. Look, so rather than you just saying asking a whole bunch of questions, why don't I think I'm going to take the chance to offer you some questions. So,
yes,
did you happen to witness the rocket launch yesterday?
I did. Yes, I seen it.
Okay.
Yeah.
So, what are your contentions with it?
With the rocket launch, like I say, the amount of space that you would need to carry fuel to carry you to 500,000 mile round trip. Where are they putting it, mate? Where's it?
Did you see how big the rocket is?
I seen how big the rocket was. Yeah.
So I don't know off the top of my hand how big it is. It is almost 100 meters tall. It's bigger than the Statue of Liberty.
Yeah.
It weighs thousands of tons, and almost all of that is fuel. Why do you think it doesn't have enough fuel?
Like I say, it just doesn't make sense, man. You know, and
which part doesn't make sense?
Just the amount of fuel that it would take to take you there and back.
Wait,
you know what I mean?
Do you have any sense of how much fuel it would take?
Yeah, but even just the pressure on the engines. Look at it. You're talking about roaring through the universe for 500,000 miles.
Yeah. Well, the engines don't. Hold on. The engines don't have to go for the whole time. They only have to get you there, and then once you're on your way, you can just coast. You can turn off the engines.
What? And just coast all the way home?
Well, no. You coast to the moon, and then once you get to the moon, you have to slow down so that you can enter orbit. Although I actually think that they might just be doing a flyby. I don't actually know if they're orbiting. But so supposing that they're orbiting, you'd have to slow down. So you'd have to fire your engines for a little bit to slow down so that you can enter an orbit. And then once you want to leave, Oh, it's just a flyby? Okay. So all you have to do then is you just have to point at the moon in the right direction, and then you'll swing around and then come back.
What, without any engines?
Yeah, you don't need any engines to do that.
So
All you need to do is be going fast enough that you can get there, and then you can turn off your engines. You can just
head
coast.
in that direction.
Yep.
And what carries you through then? What inertia just carries you all the way?
Yeah.
Wow, that's cool. That's a great theory.
Well, I mean, that's like 300-year-old physics. Like, that's just Newton's laws, right? An object in motion stays in motion unless acted upon by an external force. So, you know, this isn't really a theory. This is just how the world works.
Yeah, well, like I say, what about traveling? What about G-forces then?
Once you turn off the engines, there are no G-forces.
No, I'm talking about the G-force when they're blasting it.
Yeah, so
17,000 miles an hour.
So G-forces have nothing to do with speed. They have to do with acceleration. So I think, and I can double check this for you, but I think that like most rocket launches with people in them are going to cap out at like 4 Gs. But I can look it up for you.
Yeah, I think it's more than that. I was sure I heard it on the news. It was more than that.
All right. So the maximum G-force on the humans in the Artemis 2, they were expected to experience around 4 Gs on their way up, and up to 6.8 Gs on their way down. So yeah, I mean, like, it's a lot, but it's nothing that humans can't handle.
Well, I'm interested to see the footage that they take while they're up there anyway, and see what the community makes of that. You know,
are you going to call it fake?
Believe it, you know, and I think there is cause for them to lie to us. You know, the powers that be, for sure there is. I mean, and it's very. I mean, if you're taught something young or at a university and you take it as gospel,
you're just going to call it fake, aren't you?
What? The
rocket
trip to the moon.
Yeah.
Well, we'll see. We'll see what they come back with.
Well, you know that they're live streaming right now, right?
Sorry?
They're live streaming right now.
Are they?
Yeah.
Yeah, I've seen that before, yeah. Like I say, I mean, you know, we can be lied to. We can be manipulated as human beings, and anyone should put their hands up
so of
for
course
that.
you're just going to call it fake.
No, I'm not going to call it fake. I'm going to analyze it.
Okay, what kind of methods are you going to use to analyze it?
We're just using discernment.
Discernment isn't a method of analysis.
Well, it's a formula that we rely on anyway.
What's the formula?
At the end of the day. So basically, it all comes down to we're being created, mate, and we're not allowed. We're permitted. We're not permitted to get up there. We've not got the technology. I believe that.
It just doesn't sound like you have a way to analyze the footage in any objective sense.
Well, I've seen other people analyze it. More experts in photography and that.
Yeah. So what about the experts in photography? What about the experts on photography and the experts on physics and the experts on computer-generated graphics and the experts on all of these things who analyze it and say, "Oh yeah, it's real"?
I've never heard any of them. I've never seen anybody that prove that.
One sec, let me pull something up for you.
It's quite easy. I remember from 9/11, people found out like it's quite easy to green screen things in that, isn't it?
One sec. There's a pretty famous video of it's like a podcast of like a bunch of people who are like CGI or
experts, yeah.
Yeah. And let me see if I can find it. Is it this one? I think it's this one. Yeah, I think it's this one. These are VFX artists. Yeah, I'm not going to show you the whole video because it's rather long, but you should pull it up and watch it yourself.
Okay.
It's called VFX Artists React to the Moon Landing. And this is from 5 years ago. So you have a whole bunch of VFX artists and they're just like, responding to the video and talking about the framing and the lighting and all of that stuff. So take a look at it because these are experts. Those are experts analyzing the footage and coming to the conclusion that it's real.
Like I say, I mean, we people that didn't believe in the flat Earth might seem alien to you, but I mean, people that believe in the Big Bang seem alien to us. That thought that all this come out of just an explosion from nothing. I mean, that's just as ridiculous to us as what we sound to you.
Look, so all I'm going to say is that there are more experts who have analyzed the footage and analyzed the data that come to the conclusion that it's real than there are that have come to the conclusion that it's fake.
Okay, well, I'll look into that later myself, and I hope I bump into you another time and we can. Yes, I promise.
Okay, because
And we'll take it from there.
lying is a sin, right?
Yes, completely. Yeah.
Okay.
Okay, we'll check it out and come back to you on that one. But
All right.
I totally disagree. You've not done anything to change my argument, and the
Well,
rubber ball theory.
that's just because you've
That
kind of
is it.
ignored all of the evidence that I've presented to you.
No, I
I can
haven't.
why not I can offer you more if you want.
Yeah, real evidence.
Yeah,
Show
yeah.
me something. Show me your biggest point.
Okay,
your
so
game changer.
So let me pull up something for you really quick. I'm gonna pull up a notepad just so then we can go over some a line of reasoning. Don't worry, we'll get there.
Round Earth for dummies.
Yeah, we're gonna do round Earth for dummies, right?
Right. Okay.
Okay, round Earth for dummies. We probably can't talk about neutrinos, huh? Okay, so first, do you agree that if the sun is above the clouds and the Earth is flat, then the bottom of the clouds should always be dimmer than the top of the clouds? Do you agree with that?
No. What about reflection of the sea?
Well, the reflection is always going to be dimmer than direct sunlight, right?
I don't know.
Well,
I
a
don't
reflection always loses some energy, right?
Okay. Right.
So
well,
the direct sunlight will always carry the most energy, more than any reflection would be.
Right. Okay.
That's pretty reasonable. It's not like the ocean. It's not like the ocean is a mirror. It's not like the ground is a mirror.
It's reflective, though. It depends.
It's
if you
partially
on a white desert. It's going to
right.
come right back up again.
So it's partially reflective, but it's not perfectly reflective. So some of the sunlight will be absorbed, and so that means that not all of it will reflect back out.
So what you're saying that is the clouds are always darker at the bottom, yeah?
They should be if the sun is above it. If the sun is above the clouds.
Yeah, I know the sun's definitely above the clouds. There's no debate there.
So if the sun is above the clouds and the Earth is flat, then the bottom of the clouds should always be dimmer than the top of the clouds. Now,
but I'm not debating that the sun is. I know the sun's above the clouds.
It's also true that the bottom of the clouds is not always dimmer than the top of the clouds.
Well,
what do you think about that?
Well, if it's, I don't know.
Because I can show you pictures of the bottoms of the clouds being brighter than the tops of the clouds.
Again, I would just put that down to reflection. And what you're saying causes that.
But we're talking about the bottoms being brighter than the tops, not just that they're illuminated. You're saying that they're brighter. They're brighter, yeah.
And what causes that then?
That's the question. But here, let me just show you some pictures just so then you know I'm not lying. So here's a picture of, this is from an airplane. You can see that the tops are dark and the bottoms are bright. Yeah. Here's a picture from the ground. You can see that the bottoms are bright and the tops are dark, right? So clearly this is a real thing that happens. Sometimes the bottoms of the clouds are brighter than the tops of the clouds.
Yeah.
And so what we can then infer rather, oops, oh shoot. Sorry. Where'd it go? Why is it doing that? Where'd it go?
Sometimes
come on. Yeah.
Things on the screen, yeah.
Because like the people on YouTube can see the thing that I'm trying to pull up, but it's the wrong thing. That's why. There we go. There it is. Okay. So we agree that premise 2 is true. That the bottom of the clouds is not always dimmer than the top of the clouds. Sometimes the bottom of the clouds is brighter. And so what we can conclude, and this is just basic logic, this is called modus tollens, is that either the sun is not always above the clouds, or the Earth isn't flat.
I don't know. That doesn't prove that because, like I say, if the Earth is flat, nobody's debating that the sun's below the clouds.
If both of these sentences are true, then this conclusion necessarily follows.
The sun is not always above the clouds. Oh, the Earth isn't flat. No, I disagree with that.
Well, so you've accepted the first premise, that if the sun is above the clouds and the Earth is flat, then the bottom of the clouds should always be dimmer than the top of the clouds.
No, because again, we're still debating that it could be reflection.
But you agreed that the reflection would always be less bright than the direct sunlight.
Well, you said that. Obviously, depending what sort of.
I mean,
body it's
you agreed on it. Can you give me an example of a reflective material where the reflection is brighter than the direct image?
No, but it's equal too.
Can you give me an example of any no, a mirror absorbs 4% of the light.
Is it really?
Yeah.
Well, I don't know. Like I say, I don't know the ins and outs of it, but there's another problem with the sun. Sorry for going off topic here, but we're just wherever we go off, we can't agree on that, so we're not going to argue, yeah?
Wait a minute. So you just don't agree with the second. You agree with the second premise that the bottom of the clouds is not always dimmer than the top of the clouds, right?
Yeah, but I mean, I didn't understand your argument. I mean, how do you explain the light coming underneath the clouds then?
Because the Earth is a sphere. That's the because the Earth isn't flat, right?
Yeah, that's right. But that could still happen if the sun could.
So if the Earth is flat, the only way to have the bottom of the clouds be illuminated more brightly than the top is to have the sun be literally below the clouds.
Well, again, the clouds, like I say, things can happen atmospherically. You know, they can change the light and that. You know, okay. I mean, the clouds can.
Turns out we're gonna draw a picture. Okay. We're drawing a picture, y'all.
Pencil drawn.
We're gonna do it in paint.
It's another problem with the beams that come in through the clouds. That just while you're looking for that picture.
No, I'm drawing a picture. We're drawing it live. We're not.
While you're drawing it, the beams that come in from the cloud, check the angle of them. Measure the angle of those beams coming through the clouds, and you'll see that it's a lot closer than what we're told. The sun is a lot more local than what we're told.
I don't really see what that has to do with the claim here.
Well, the claim is that we've been lied to. That's what the whole show is about.
Okay, so let's say that you're standing. Sorry, I just got to make this. I want this to be a narrow pen. Give me a narrow pen. Okay, fine. We'll move this over here. Okay, so let's say that you're over here, right? This little stick figure is you, right?
Yeah.
And I'm gonna draw a little cloud.
Mm-hmm.
Right, there's a little cloud. And now I'm gonna put the sun. Sorry, one sec. I'm gonna put the sun in one location. I'm gonna put it above the clouds, right? Because we agree that the sun should be above the clouds. So the sun might be here, right?
Yeah.
So the sunlight goes in all directions. I think we can probably agree on that.
Yeah.
It goes in this direction and this direction and this direction and this direction and this direction, and it goes in every single direction wherever. So some of the sunlight is going to hit the top of the cloud, right?
Yeah.
It's not going to pass through the cloud because the clouds are opaque. But
it'll diffract light in a certain way. They can
a little bit, but it's not going to pass through to the bottom of the cloud. It'll illuminate the top of the cloud, and it won't illuminate the bottom of the cloud. And then you're also saying, well, it could go down here and then bounce off the water and illuminate that way, right?
Yeah, could.
But water is not But water is not 100% reflective. For example, neither is the ground. And so what you'll end up with is any of the light that is illuminating the top will be brighter. It'll be brighter up here in the top half than it is in the bottom half.
Yeah, but on a flat Earth, I mean, the sun could still go to different elevations. I mean, if it was circled around the flat Earth, if it is
always above the altitude that the clouds are at, then this will always be the case, that the top will always be brighter than the bottom.
Well, there's an easy way to debunk it that the sun might. Look at your rays there in your drawing there, right? The way that you look at, I could show you pictures. Well, you could find them faster than me with your expertise on the computer. But I mean, if you measure those beams, and that can tell you the exact distance, mate, and it shows you that the sun's a lot more local.
Yeah, you can do that. This is a separate experiment. This is like, you can do this with the Eratosthenes experiment. And what you find is that the sun is essentially infinitely far away.
Well, like I said,
anyway, we don't even have to do anything that complicated. We don't have to make any measurements or take any data or anything. All we have to do is recognize that because a reflection always loses at least a little bit of energy, the bottom of the clouds should always be at least a little bit darker than the tops of the clouds.
I know, but we didn't know enough about the way the light diffracts in the clouds. You know what I mean? Clouds
sure we
diffract.
Do. That's how they
like shining a light into
This is how the clouds get illuminated. The light enters the clouds and then it bounces around in a very small. It has a very small penetration depth, so not a lot of light actually penetrates. It bounces around, and so the surface of the clouds get illuminated. So if you have direct sunlight, if you have direct light onto a cloud, the surface of the cloud will be illuminated from that scattering. And so what we see is that the top of the cloud should be brighter than the bottom of the cloud.
I know, but there's too many variables in the
no, there's really not. There's really not.
The way that light can diffract against all the water molecules is uncalculable. You know what I mean? We can't predict.
No, it's actually very calculable. This is called a scattering problem, and you can absolutely calculate the penetration depth of light, for example, in like a suspended liquid in a gas. This is absolutely a thing that you can do.
I'll take your word for it, but like I say, I need to look into these things.
So do you have an alternative explanation for how the bottom of the clouds could ever possibly be brighter than the top of the clouds?
Okay, because the sun moves in an arc over the flat Earth.
How is it that the top is gray but the bottom is orange?
Well, because like I'm saying, because the sun goes over the flat Earth in an arc, perhaps, that once it goes down to the bottom on the green side, past the green, then it can let the light in, like what you're saying. So it doesn't have to be a sphere. It could be like a rainbow-shaped arc.
So look, I don't understand. Regardless of where this circle is, that circle will always be above the clouds, right?
No, if it's moving in an arc over your scenario there.
Let's say it moves on top of me, then it's still above the cloud, right? It's still higher in elevation than the clouds.
No, maybe it moves. See,
are you saying that it can move up and down?
Let's pretend it's at the top of the firmament for argument's sake.
Can it move up and down? Does the sun move up and down?
In an arc.
Then it doesn't. Right. I understand.
Left to right in an arc.
Look, I understand what you're saying. You're saying that it moves like this. It moves like around like this, but obviously bigger scale. Obviously bigger scale, but it moves like, it goes like around.
It moves like that, but it could also move higher and lower, so it could be like a rainbow effect.
Wait, so you think that it can do this? You think it can move up and down?
Yeah, it can move up and down. So there's a whole rainbow right over.
Are you telling me that at some point the sun is lower than the clouds?
Never that.
Okay, then it doesn't matter how low it goes, as long as it's still above the clouds. You still have some explaining to do.
No, I'm talking about if you draw a rainbow shape right over your whole scenario there. Draw a rainbow right past there, and then make the sun go past the Earth there, and that trajectory whilst elevating.
Well, when it's over here, it would be below the clouds.
Yes. Okay. So that's how the light could get in.
Wait. So you're telling me that the sun can be below the clouds? It could be over here.
It could go right past the flat Earth. Say the Earth is flat. It could go right past your green
Hold on.
part.
Could the sun be over here?
The sun could be there. Yeah.
Then it can be below the clouds.
Well, of course it can if it moves in that trajectory, yeah.
Okay, so you think so then we agree. I'm glad that we agree that this argument that I've offered you is correct. That either, because it's possible for the bottom of the clouds to be brighter than the top of the clouds, then either the sun is not always above the clouds or the Earth isn't flat. And it seems like you've decided that means that the sun is not always above the clouds.
No, the sun is always above the clouds, and that's what I'm saying.
You just agreed that it wasn't.
No, it obviously is, because obviously there's light. You've proved that there's light under the clouds.
Let's back up just a little bit. You said that the sun could. Oops. You agreed just a second ago that the sun could be. Sorry. You said that the sun could be over here, right?
Yeah, if you widen your rainbow shape there, make it come right off the edge of the
so just to be clear, this is below the clouds, right?
Maybe, perhaps, yeah. Maybe it drops down past there.
So you agreed that you just said that the sun could be below the clouds.
It could be, yes, in order to get light under there.
But then 2 seconds ago, you said that the sun is never below the clouds.
No, never on a sphere, no. That's what I'm saying.
We're not talking about the sphere. We're talking about a flat Earth. We're talking about the flat Earth. We're not talking about the sphere.
I'm talking about the flat Earth. Okay, the sun could move in that trajectory. If you
so
widen
in your view, it's possible.
That rainbow shape, if you widen the rainbow shape so that the rainbow was coming off, then the sun could come lower the clouds then.
So in your view, on a flat Earth, the sun could be lower than the clouds?
It could leave that, yeah. It could go off the edge of it, yeah.
Okay.
It could drop below the edge of it.
Okay. So if the sun could be below the clouds, so you know how it's like 6 p.m. It's that you know, I don't know what part of the world you're in. I mean, I can guess, but let's say it's sunset at 6 p.m. for you in Scotland.
Yeah, that's correct.
Okay, maybe it's like August or something, or September. Sunset, it's 6 p.m. So in your view, it sounds like what you're saying is that at 6 p.m. the sun should be below the clouds.
Yeah, well, that's at dawn. That's what dawn is, yeah.
Or at dawn. We can say it's 6 a.m., 6 p.m., whatever. Either way, the sun is below the clouds at that time, right?
Yeah.
Now, at 6 p.m. for you, it's noon in New York, right?
Yeah, that's right. Yeah.
So when it's noon in New York, is the sun still below the clouds?
Well, like I say, I don't know the actual trajectory of the sun, but what I'm saying, it is possible that it goes past the flat Earth. It could circle right round the flat Earth. It could
Here's
walk.
the issue: if that were true, then it should be nighttime for this. It should be nighttime for everybody at the same time, right?
Not necessarily.
If it goes below the flat Earth, then nobody should be able to see the sun.
Granted, yeah, but like I say, it could, yeah.
So it can't go. It can't be doing that.
No, it couldn't be doing that, but it could go down to the bottom. It could go down to the same level as the flat Earth, and then come back up again. It could do that
but,
easily.
So that means that it should be sunset for everybody at the same time.
No, it doesn't, because it could rise on one side and then go around the other.
Look, so when the sun is over here, is that sunset or sunrise?
Well, it depends where you are. It depends. You know what I mean?
Well, that's kind of my point, actually. My point is that if you say that at sunset or sunrise for you, which is when the bottom of the clouds are illuminated, right? That's when you can see the bottom of the clouds being illuminated, the top are dark. That must mean that the sun is below the clouds in order to make the bottom bright and the top dark.
Yeah.
And so it would mean, you know, the clouds are a few miles up, maybe 3, 4, 5 miles up, something like this.
Yeah.
So that would mean that at sunrise and sunset, or, you know, dawn and at dusk, the sun is actually only a few miles above the Earth, right?
No.
No?
Miles away, obviously. If you widened your rainbow shape,
I said a few miles. I did say a few miles.
Yeah, but if you take your rainbow shape and put it past the terra firma that you've got written there, drawn.
Look. Maybe you're just missing the point that I'm making. My point is that in order for the bottoms to be illuminated, it must be the case that the sun is lower than the clouds.
Yeah, dependent on where it is, where it's sitting on the flat Earth, yeah.
Right, and so
like, if you've got a dinner plate, and you've got a dinner plate,
look,
dinner plate sitting there, that's a flat Earth.
Let me just land this plane. If the sun is lower than the clouds for one person because it's, say, sunset for them, then that means that it's lower than the clouds for everybody at that exact same time.
No, not necessarily.
So are you saying the sun can be at multiple different heights at the same time?
Well, it can be different heights for wherever it rises on that side. Yeah, that's dawn for them. Then it could go right round. It could.
Okay, so I'm going to extend this over a little bit.
Yeah.
Let me show you. Let me elaborate on what I'm trying to convey. So and then we can get rid of. Ignore that the black arc, right? We'll just draw a new one. There's the new one, right?
Yeah.
Okay, and so what we're going to do is we're going to draw another person. Let's say that this one is you in Scotland.
Yeah.
And obviously there's not a whole lot of land to your west, but to your west, but we'll just imagine that there is. So we'll just draw another person. Let's say that this person is in New York, right?
Okay.
So technically it's still a little bit small. If this direction is west, then this would be sunrise, right? Because sunrise is in the east. This direction. So this is sunrise. So sunrise for you. The sun is below the clouds, right? It's lower in elevation than the clouds. Now let's draw sunset for you. Sunset for you is going to be somewhere on the other side, maybe over here, right?
Yeah.
Something like this. So here's sunset. And because it's sunset for you, it's still lower than the clouds, right? So we'll draw the clouds over here. We'll draw a dividing line just so then we can see that it's actually darker up above.
This is is that me there? Is this the guy from New York underneath that cloud?
That's the guy from New York underneath the cloud.
Right, so that's New York under there, yeah?
Yeah. So here I'll label my drawing. So we have New York and we have Scotland.
Okay.
So now from this guy's perspective, so this is sunset for you, but from this guy's perspective, it's noon. I mean, it's obviously not to scale. Maybe the guy should be directly under the sun, so maybe we'll move him a little bit. Because, you know, when the sun is directly when it's noon, the sun is directly over you, or at least near enough. So here's our actual New York guy. Yeah. Okay. We'll just take New York and we'll do, take that, move it over here. Okay, great. So we have our New York guy. Now it's noon for this guy, but it's sunset for you. So from this guy's perspective, it should be that the cloud is still, or the sun is still under the cloud, even though it's noon.
Well, we don't know. How would that be?
Because the sun can't be at different heights at the same time. So if it's under the clouds at your sunset, which is his noon, then it has to be under the clouds at his noon.
I don't know. Like I say, it doesn't. Nah, we don't know. Like I say, I didn't profess to know that. Like because.
Well, it sounds like this is where you say, yeah, I don't know how that works, but it can't be right. This is pretty straightforward stuff, right? If the sun can't be at multiple heights at the same time, right?
Yeah. Because
it can't be in more than one place at once.
I don't know the different elevations, mate. You know what I mean? It could be different elevations. I don't know.
So we don't need to know the exact elevations. All we need to know is whether it's above the sun or above the clouds or below the clouds. That's all.
Okay, that's a good. Yeah. I agree
so
with that, yeah.
And if in order for the bottom of the clouds to be illuminated at your sunset, which is when the sun is over here, that means the sun has to be lower than the clouds. Then that means that from the New Yorker's perspective, the sun is also lower than the clouds, even at noon.
We can't say that because we can't really say what's in between there. You know, you've got a lot of mountains, you've got a lot of different elevations. It could be, I don't know.
What do the mountains have to? I mean, what do the mountains have to do with anything? There's no mountains. Obviously. There's no mountains between Scotland and New York that are higher than clouds.
Yeah. Well, like I say, I'm not really great at geography either. But like I say, yeah.
It's just ocean.
Yeah, it's just ocean between us. Yeah, so they say. Held down by gravity, you say.
Yeah. But the point is that it's like, I mean, we could even draw this more accurately, right? We'll just draw a little rectangle, and then we're going to.
Is, mate, the world's much bigger than both of you or I. You and I combined.
There we go.
We didn't know, mate. We didn't.
There we go. Now we have it. Now we have an accurate depiction of the of New York and Scotland. There's ocean between us, and so now. There's just nothing in between. There's the clouds over here that you can see that have the bottom of the clouds being illuminated by the sun, which means that this person at noon, should also see the bottom of the clouds be illuminated, and should see the sun be lower than the clouds are.
Well, there's a lot of things in between us, mate. Like I say, I didn't really know. I don't think if this is your best argument.
There's ocean in Ireland.
Yeah, if this is your best argument for proving around Earth, then it's not convinced me. And I've obviously not convinced you either.
I mean, it hasn't convinced you, but like, you've agreed that the sun is sometimes lower than the clouds, which, keep in mind, planes can fly higher than the clouds.
I'm saying there's reflection definitely under the clouds, but we've not looked deep enough into like the refraction of the clouds and things like that.
I have looked deeper into it. It doesn't save you.
Well, if you've looked into it, that's fair enough. I can't argue with that because I'm not a physicist, but I'm just telling you what I see is perception. And yeah, like I say, the world's much bigger than us. The universe is bigger than us. Just because the universities have given you a narrative, you know what I mean?
No, you don't need universities to know this. Euclid would have known this. This is basic geometry.
Well, I disagree with that because, like I say, there's too many.
You disagree with basic geometry?
There's too many variables.
There's only one variable: whether the sun is higher or lower than the cloud.
When I see a ball that can take a substantial body of water spinning on it, mate.
Okay, so now you're pivoting because you don't have a response to the sun being lower than the cloud.
Well, I can't prove that. Not based on your model. I can't prove anything there. No, I can't.
This is your model, by the way.
No, this is your model.
We're for the sake of this case, we're assuming that the Earth is flat, and we're showing that it doesn't make any sense.
Yeah, flat, but not totally flat, not pancake flat.
Nobody
you know
is.
what I mean? It's
Look. So, what's the tallest mountain in Scotland?
Ben Nevis.
Okay, how tall is it?
I don't know.
Okay, the tallest mountain in Scotland, famously, is less than a mile tall. Right? Clouds are higher than a mile up, so it doesn't matter whether there's any topography between you and New York. It won't prevent you from seeing the bottom of the clouds being illuminated or the top of the clouds being dark. This is just,
like I say, I'm
not basic geometry.
I'm not agreeing with you that the sun went. I'm just offering a scenario, a possible scenario. I'm not agreeing, mate, that the sun, you know what I mean, that it dips below to cause that illumination.
That's your only option, right?
No, I'm not agreeing fully that there could be another explanation for light shining underneath the clouds.
Okay, do you have an alternative explanation for how the sun could be above the clouds but have the bottom of the clouds be brighter than the top of the clouds?
Yeah, well, like I say, if I shine a torch into a ball of cotton wool, it'll diffract all over the place, mate. Yeah.
And yet, the top of the cotton wool will be brighter than the bottom.
Well, I'd have to go and grab a couple of balls and test that with an LED torch.
Yeah, do it.
Really. Well, like I say, I think the world needs more free thinkers. We need to look more into it. And obviously, going to university and that does make you part of the system, mate. And you're not allowed to think with that system. You're not allowed to think out. You're allowed to think out the system, but if you come up with any sort of radical ideas or anything useful to this planet that is non-profit making, you'll not be allowed to go any further. And you know that deep inside yourself. I know you do.
No, I mean, it's just not true. Like, this is a false narrative that you tell yourself to try to distance yourself from the academics of the world because they do science that is more sophisticated than things that you can understand. Which, look, I get
science
it.
Doesn't explain everything.
Not everybody can understand everything. I don't understand a lot of what biologists do. I don't understand a lot of what chemists do because I'm not a biologist and I'm not a chemist. But I don't go around saying that it's all just a giant conspiracy because I don't understand what they're saying.
Well, you're saying? Well, can I just ask you one question? It's
sure.
Slightly off topic. Do you believe that we're created or we just happened at the Big Bang?
I don't think that that's a true dichotomy. I don't think that we just happened because of the Big Bang is the only alternative explanation from a creator.
Well, what is then? I didn't see. If we weren't created,
so
then
either we're created or we're not. That's the true dichotomy.
Created. We're definitely created. What do you think? Do you think we're not created?
I don't think that there's a creator. No.
You think we're just circumstance?
No, that doesn't. It just because I say I don't think that there's a creator, that doesn't mean that we are just circumstance.
Well, I disagree. I think we've definitely created. I'm not saying I'm religious. I'm not even religious, but I know for a fact. I feel it in my heart, and I've seen evidence of it. We've been created.
It sounds like you're religious.
Nothing else about it. We never crawled out any primordial slime. You know what I mean? That just doesn't happen, man. It doesn't happen.
Spoken like a true person who wants to understand the world around them.
I do want to understand the world.
If you did, then you wouldn't be misrepresenting the scientific view. Rapid recycling. You've been on for a while, so I'm going to let you go. But thank you for being here,
gentlemen. Listen, interesting. Anyway, thanks.
That was something. Yeah. So I wasn't wrong when I said that he wouldn't be able to follow the neutrino stuff, right? All right, let's bring up our next guest. We have a guest in Discord, so let's bring them up. Let's read some super chats before we do that, and then we'll bring up our guest from Discord. From Rodrigo Samante with the two euros. Oh, I can hide this stuff now. Nice to see you. Hope you're doing well. I'm recovering. I'm doing better every day. From Dan O'Connell with the 279 Canuck bucks. Glad to see you back, Dr. Blitz. I'm glad to be back. From Brian Peck with the $2. Dubay does not debate and doesn't accept invites. That makes sense. I believe that. From WT Pass with the 2 Canuck bucks. Keep up the good work. I will try. From Brian Peck with the $2. By the way, glad to hear it wasn't a gist. Nasty tumor. Well, gists I think are actually probably the best case scenario if you're going to have like a tumor there, because they're pretty slow growing, right? But I don't have that. I didn't have that. From Spamuels with the $20, welcome back, looking good, homie. I appreciate that. I've lost some weight, which is bad. Need to gain some weight, but we're on the road to recovery. From L'Oreal with the $20, thank you so much, L'Oreal. Always good to see you. Welcome back, Dr. Blitz. You've been so strong. Your wife is an absolute queen. You hear that? I don't know where she went. I'm okay. And your mom is incredibly sharp and knew something wasn't adding up. I admire all of you. Wishing you and your family the best. So, and this just to clarify something. It was reasonable for my oncology team to investigate cancer. Because if they were wrong about it being cancer and it just ended up being an abscess or an infection, then it's significantly less serious. So the cost of them being wrong is low compared to the cost of them being wrong if it was cancer and they assumed it wasn't. So the fact that my mom asked this question, hey, what's the deal with this with the elevated white blood cell count? She was asking this because she hoped it wasn't cancer, not because this was a definitive sign that it wasn't cancer, but more that she hoped that it wasn't cancer, and she happened to be right. But the responsible thing to do was still to run those tests, because if it was cancer, we needed to know as quickly as possible, right? You don't want to take time to rule out other options. From Brian Peck with the $2, caller speed running 11-year-old talking points. Yup. From Blake Walker with the $10, I'm overcome with joy to see you back online. I'm here and hopefully here to stay. From Juso here with the €2, nothing makes sense when you don't know anything. That's exactly the issue, right? From Ryan Cooper with the $2, per this guy, why did the goalpost cross the road? I should start using that. That's funny. Yeah, somebody says, of note, malignancy can cause elevated white blood cell count even without infection. So it wasn't a specific elevated, it wasn't just general elevated white blood cell count. It was a specific elevated, a specific kind. It was like neutrophils or something like this. There's a specific white blood cell count that was elevated, which I guess, which is, you know, indicative of something. But, you know, it wasn't just like general white blood cell count. It was a specific kind, but I'm not a medical doctor, so I don't know that kind of stuff. From Ancient Irish Celt with the €5. Stayed up to watch the launch last night. Incredibly exciting to see. Thank you from Ireland for the science education by mocking flat earthers. Yeah, we do our best. I watched the launch too. It was incredible. Like, it was spectacular. I'm glad I got to see it. I was clenching my fists, like really scared that something was going to go wrong, because that would have been devastating. From Mr. Gust with the 100 Swedish kroner. 24-hour sun game over. Yeah, exactly. From Germs Rossalina with the $20, I once debated a close friend who's a FLERF. After disproving all his crap, he said, but you have a college degree, right? I said, yeah, I have 3. He replied, oh, then you're just indoctrinated into the lie. Yeah, that's the issue, right? Like, since when is education a bad thing? From 49 Perfect with the $5, caller, makes claim. Dr. B disproves claim with video evidence. Caller, I don't know math, so you're wrong every time with these yahoos. Yeah, look, more people should learn math. We should encourage mathematics education. From the Rabid Squirrel with the $2, all hail the emissary of the lava lamp. Indeed, I have returned. Just a few more to go. From Chatter Cheese with the $7, going to the MUN and Kerbal Space Program should be required curriculum in schools. Oh my god, yes. I learned so much orbital mechanics from Kerbal Space Program. In fact, probably all of the orbital mechanics that I know, I learned from Kerbal Space Program. Because it's so efficient. It's so good at teaching it and learning it. From Unfornicated with the $10, Larry Basinger listened in on Apollo 11. I ran the numbers. It was possible to hear VHF PLSS comms on Earth. Independent skeptical witness wanting to see if NASA hit anything. Recorded Nixon call. Yeah, I've heard about this. I should actually probably add this to my debate notes, because you know, I just don't have it somewhere. I'll add it to my to sort. We'll put it in the moon landing or something. What is his name? Larry Basinger listened in on Apollo 11 radio. Find more details. Yeah, so that is a really good point. But they might just say it's fake. From Cherry Bum with the $10, glad to have you back, Dr. Blitz. Indeed, I have risen. From Ryan with the $5, you have to tell everyone you talk with about the final experiment. It wrecks every flat earth model. The earth is round and Christ is king. God bless. Well, look, I disagree with you about Jesus, but I do agree that the earth is round. The thing is a lot of them think it's fake. And I actually like the sun example, because you can see them squirm and try to wiggle their way out of it. From Ekipo with the €5, put a rainbow on a picture and a smiley face on the sun so that FLERFers can understand the logic. Yeah, I should do that. I really need to just like make a diagram that I can pull up on the regular. From Ryan Gasling with the £5, I agree with the caller now. The lack of consistent sunshine in the UK is proof of the flat earth. True. Yeah, you got us there. From Garain with the $2, FLERFS all failed elementary school geometry. Yeah. Or they just don't remember it. From Brian Peck with the $2, that guy is free to think and chooses not to. That's one way to put it. I just don't understand, like, what's the opposition to actually, like, seeking out things that are complicated? From Binary Ghosts with the $5, flat earthers are spending a lot of time and energy on a non-problem. I really wish they would put that energy to other actually productive pursuits. Yeah. From Iconoclodge with the $5, praise to Atheismo and the Lava Lamp. They have healed Blitz. Indeed. Indeed, I have been healed. And from Matt Lindley Design with the $2, I'm not religious, then explain religious beliefs. You got me there. We have one more and then some cash apps to read. From Binary Ghosts with the $5, on the subjects of mathematics education, I think discrete math needs to be a required high school course. People really need to learn to do basic proofs. I agree. I'm just not sure if everybody would be able to understand it. I just don't know if like that is on good days. I often want to think that like everybody has the capability to do this, but then on bad days, I'm like, maybe not. Right. All right. Now we have $15 from Magdalena saying, glad you're doing well. I listen to you whenever I get a chance. Well, I appreciate that. I'm glad I can provide you with stuff to listen to. And from Sheila with the $5 for yay for your great news, Liberati's Dragon. Yeah, the news is quite good. All right, y'all. Let us move on to our next guest. This guest will be coming in from Discord if they're still here. Let's bring on Abject. Abject, can you hear me?
Hello.
Your audio is a little bit muffled. Do you want to try, I don't know, is there something that you can do to fix it?
How does this sound?
It sounds okay. We'll make do.
Okay, what's your name?
You can call me Blitz.
Blitz, okay. I'm Liam.
Liam, nice to meet
is
you.
It all right nice to meet you too. I was wondering if I can ask, I guess my question would be more focused on gravity.
Yeah, we can talk about that. But before we do that, do you think that the Earth is flat?
Not really. But
okay. But then why'd you come up?
Not really.
If it says opposition only.
So it's more I'm trying to understand gravity, and obviously if your understanding of gravity is true, then the Earth could not be flat. But I have a few things I don't understand about gravity, I guess you could say.
Okay, I'll give you a few minutes, but then we got to cut it because it does say opposition only. So what you got for me?
Okay, so gravity. The idea is all mass, I guess, has gravity. So the larger an object, the more gravity. The more dense it has, more gravity. So I guess more atoms means more gravity. Is that right?
Well, it's really just like a count of how much energy a thing has. That's the thing that's proportional to its gravity.
So when you say energy, my monkey brain thinks like power. So what do you mean by energy?
So you can have like, you can have stuff that's massless, but if you put it in a box so it's bouncing around, well, there's still energy in that box, even though the things that are in that box are all massless. And so like the box will have energy, and so the box will have gravity.
So does light weighs? No, does light have gravity?
Light does have gravity. Yeah.
Oh.
It's very, very small for like any normal amounts of light that you would experience in the universe. But like, yeah, it would have gravity. Yeah.
So wait, so small particles are affected by gravity?
Yeah.
So when I obviously I know a diagram of an atom isn't necessarily how it actually is in real life, but are the other particles around it? Are they using gravity to orbit?
No, they're using electromagnetic forces. The electromagnetic forces are much stronger than the gravitational forces. The gravity, you could calculate how big of a difference the gravity would make, and you'd find that it's like negligible because they're so light.
Okay. So I guess my confusion would be then. So it makes sense if the magnetic forces are stronger on the smaller scale, but on a larger scale, say you have a expansion and explosion, and there's a bunch of matter shot across the universe.
Yep.
And that happened. I guess from the position we are in the universe, that happened. Earth was. I don't know how many. Was it 5 billion years ago? Or was that when Earth was created?
Earth formed about 4.5 billion years ago. Yeah.
Okay. How long ago was the Big Bang?
13.8. 13.8 billion years ago.
Okay, and that's different from different places in the universe, right?
No, not really.
Okay, so why did when everything expand out, if it's been so long, like if mass pulls everything together, why isn't everything
hasn't
pulled
it
together? And I
recollapsed?
often hear
Well,
that
so
I hear that there's expanding space between things, but if that's true, why, like, is anything near each other then?
So what you can think of the you don't even have to think of it as expanding space. It's not even relevant to the point here. The point is, so it seems to be the case that the universe's explosion is getting faster rather than slowing down, and that just indicates that there's something that we don't know what it is yet that is, in some sense, has some sort of repulsive gravity. We call that thing dark energy. That's all.
Okay.
So and like before we discovered this, the understanding was like, oh yeah, it is slowing down. It just started out really energetic, so it's just taken a while. But we know better now because we've taken more precision measurements. But look, Abject, I'm going to let you go because you did ask your questions, and this is opposition only. But thanks for being here.
Okay, well,
Sorry for cutting you off early. Let's talk to Austin Carpinello. Austin? Austin? Austin. All right, it looks like Austin's not connecting. Let's talk to this guy with a guitar in his username. We'll call him Guitar. Guitar, how's it going?
It's going good. Ever since I cooked you on allegedly in his live stream.
Have we spoken before?
Yeah.
Who are you?
Do you remember when we were talking about like the universe beginning and Jesus' resurrection, and then like I brought up the second law of thermodynamics and the expansion of the universe?
You mean like 3 days ago?
Yeah.
Oh, yeah, sure.
And then you said Jesus resurrecting from the dead would violate the second law of thermodynamics, and I told you, but if there is a God, then miracles are possible.
Yeah, sure. So do you think that the Earth is flat? Do you think that the Earth is flat? Hello?
Oh, my bad. I was on mute. Oh, your arguments don't prove it's not.
Wait, that doesn't really answer my question. Do you think that the Earth is flat?
Could be, but like your arguments don't prove it's not.
Why do you think so? So you say could be. So like I'm asking what your view is, or are you agnostic on the
I've
issue?
never been to space or anything. You know.
Have you ever been to Australia?
No.
Okay, so do you hold the same standard that that you're agnostic about whether Australia exists?
Well, space is a whole different story.
Well, wait a minute. So why'd you bring up whether or not you've been to space if you're not using the same standard of evidence?
I can possibly go to Australia. I just don't want to. But if I could go to space, I'd go.
How do you know you could possibly go to Australia?
Because I can get up right now, walk, go drive.
Just so you know, Australia is an island.
Okay, I'll get on a boat.
Well, how do you know that you'll end up somewhere called Australia?
Because we have maps.
Oh, we also have maps of space. So like, where do we go from there?
The thing is, though, it's different because you can't really just get up and go to space.
You can't just get up and go to Australia either.
I can right now.
Do you own a private boat?
I own a private jet too.
Oh, okay, so then do it. Otherwise, you should be agnostic, right?
I don't want to go to Australia. I don't need to. I can look at the videos.
Oh, okay, but the videos from space are not sufficient evidence?
CGI.
Okay, so it just sounds like your standard of evidence is arbitrary.
No,
or rather, I should say inconsistent.
Honestly, this analogy fails because when we're talking about space, it's a whole entire different story. When we're talking about Australia, that's where people actually live.
Sorry, what's the difference? What's the different story? What's the meaningful difference?
So when it comes to space, it's widely accepted that it's not real.
Oh, okay. So you're trolling?
No.
It's widely accepted that it's not real. Well, I think that that's strictly false. So we'll let him go for trolling. Oops. Let's read some super chats. From Devil's PD with the $20, if higher education is a conspiracy, can we encourage some brave FLERFers to go get an education as undercover spies to expose the conspiracy? I would love for them to do that. It would bring me so much joy. Like, I've challenged, like, Witsit. I'm like, look, I've challenged people like Witsit and, you know, all these people who are like, you know, if I could, or, you know, I could go prove it wrong if only blah, blah, and I'll just go do it, right? From C-Bar with the $5, can I have your autograph? I guess if you ever saw me in person, sure, but I would be very awkward about it. Like, I'm an incredibly socially awkward person. From Miko Makapo with the £10, no, or Scottish pal Ken. Witsy cried, only way his bum was out the window. Or in other words, our Scottish pal, remember? What was his name? Anyway, his was talking nonsense. I did my best, okay? I understand that it's probably like, is it racist to do a Scottish accent? Or does it not count? From Ryan Gasling with the £2. So the caller just wants to ask a physicist? Yeah. And from Binary Ghost with $5, the Earth is shaped like a bowl. Antarctica is the top rim of the bowl. North Pole is the very bottom of the bowl. We exist on a kitchen countertop. That makes sense. That makes sense. I think we figured it out, everybody. Sorry, I'm just checking. I have some notifications that I have to double check. Guys, if you tag me, I'm probably not going to see it during the live stream, unless you're like a mod. So apologies for that. Oh, that guy's name was Matthew. Okay. Well, now we know. All right, hold on, sorry. Oh, Matthew's back. All right, let's bring up Matthew again, just for the lulz.
Yeah, why'd my profile picture change? What the heck?
Welcome back, Matthew.
What's up?
So, do you want to recant your claim that it's widely believed or widely known that space is fake?
Yeah, I don't agree. I just wanted to talk about God, so I mean, if we can't, I'll just wait until like your live changes.
Okay, goodbye. Oh. Yeah, currently, my muscles, I actually don't know. I actually don't know what my insides look like right now, but I have like an incision that's about yay long down my abdomen from a little bit past my belly button to like an inch below my my rib cage. And so, you know, my abdominal muscles are not really pulling their weight, if you will. So sitting up and stuff like that is rough. My back has been doing my lower back has been doing so much work to keep me up and walking, basically because I'm just like permanently like this. And so like my lower back is pulling all of the weight to like keep me from falling over. So yeah. Yeah, you'd probably have to swim a bit to get to Sydney. That's very, very, very true. My incision actually isn't, I sneezed yesterday, it was awful. My incision actually isn't so bad. I mostly have like intestinal pain kind of around it, which is not great. I don't love it, but we're making do. All right, y'all. So remember to, if you're watching on YouTube, make sure to like the live and hit subscribe, whether you're watching on the main channel vertically at Blitz PhD, or if you're watching horizontally at Dr. Blitz Debunks, make sure to subscribe. And if you haven't subscribed to the alternative channel, the at Dr. Blitz Debunks channel, make sure to go do that. We're trying to grow that channel so that way then we can have a little bit more reliable revenue so that I can, basically the goal is to get to the point where my revenue is sufficiently reliable that I can experiment more and start trying long form content on YouTube, like making long form videos. But in order to do that, I need to have more time, which means I need to be spending less time doing things like, you know, well, I basically need to have more passive income so I can adjust my focus. So if you guys want to see long form content, make sure to go subscribe to the second channel. Anyway, let's bring up Lil Pabs.
Yo,
Lil Pabs, how's it going?
I'm good.
Glad to hear it.
I wanted to say, bro, I love you so much.
I
hope
appreciate
everything's
that.
going well.
I'm doing okay.
We all love Dr. Blitz. Yes, we. Yes, we.
All right, I'm letting him go. Less work you work, more shows. All right, let's talk to Third John. Are we Charlie Kirk? No, we're not Charlie. We're not Charlie Kirk. Third John, how's it going?
Hey, what's up, Doc?
Not a whole lot. John, what shape do you think the Earth is?
Round.
Okay. Why did you join?
I don't want to, because I was trying to find the link to your paper you mentioned earlier.
You will not, and I will not give it to you.
Oh, okay. Sorry, I thought it was published.
So, it is. I try not to mix my social media persona with my academic persona.
Is there a place I can find it? Do you mind sharing?
I will not share that, no.
Okay, no problem. All right, sorry to waste your time.
You're good. Yeah, that's for my own safety. Gotta drink some Gatorade. Gotta keep my fluids up. Apparently Science with Freddy is in the... Oh, Science with Freddy was muted. I guess he doesn't want to come up. Let's talk to Clay. Clay, how's it going?
Hi. I don't think Flat Earth is dead, but I don't believe in it. Like, it's unfortunate that we live in such a age of information and knowledge, and yet there are some people that, because of the technologies that we have, get into these algorithmic echo chambers and perpetuate lies. Yeah.
I agree it is sad, but that's not really the subject here. So I'm gonna let you go, but thanks for being here, Clay. Yeah, so look, so I understand that you can disagree with me if you think that Flat Earth isn't dead, but you also think that the Earth is a globe. That's kind of like, read between the lines, right? Like, I'm looking to talk to people who think that the Earth is flat. You know, maybe Flat Earth is finally dead. Maybe all of the Flat Earthers have moved on to, you know, the, I don't know, concave Earth, or maybe Artemis deniers or something like this. But I suspect not. I suspect not. So make sure to send this out to all of your friends, all of your peeps that, you know, think that the Earth is flat. Make sure to share it if you're watching on TikTok, like the live. We're only at 48,000 likes, and we have over 600 people in here. They've moved on to the nukes aren't real grift. Have they really? Like, is this like a more... Like, I saw one guy that made a video about nukes not being real. But, like, is this like a popular thing that's gaining momentum in, like, the live stream space? Yeah, they're on the NASA Live, I know, right? Wonder how many people converted from Flat Earth to common sense after watching Artemis. Oh, probably very few. Have I ever tried Kerbal Space Program? I absolutely have. Yeah, if Science with Freddy wants to join, he can join if he wants to. It'll be a shit show, but like, we can invite him up. Oh, he follows me. That's cute. Freddy, how's it going?
Hey, how you doing today?
I'm doing okay. Freddy, can I ask something of you?
What do you think of that Artemis flight? What do you think of that
Freddy,
Artemis
Freddy,
flight?
before we start, can I ask something of you?
Oh yeah, what's that? Am I a flat earther?
No. Can we agree that we will let each other finish sentences before we, you know, like before anything, just like a baseline level of respect will be like no interrupting, but that also comes with no rambling. Can we agree that we'll do that?
Like now?
Yeah, like right now. Can we agree that like that will be the baseline for our conversation so that it's a normal conversation between two adults?
I always strive for that.
Okay, cool. So you wanted to talk about the rocket launch. What'd you think?
Oh, I thought it was amazing.
Right? Do you think that it was faked?
Yeah. What, the rocket?
Well, the whole thing.
The whole thing? Well, the whole thing, there's fakeness in it. But did the rocket go in the sky? Yes, the rocket went up. Just
So
like if I launched a bottle rocket, the bottle rocket would indeed launch, unless it was a dud.
Sure. So where do you think it went?
I think it went up and then it started to curve like sideways as I saw it.
Yep. Yeah. But Does
Yeah.
that doesn't mean
And
that
then,
it went
then we lost sight of it. And then we lost sight of it.
right? So where do you think it ended up?
Well, if we lost sight of it, then it shows it in space with the camera alongside of it flying through space.
Yeah. So, but where do you think that it ended up?
Well, where did the camera in outer space come from? Is what I'd like to know.
Well, there was a camera attached to the rocket.
Oh, alongside of it
Yeah.
to show
right?
the entire length.
Oh,
to show the
wait.
entire
Are you
length.
are you talking about the visualization?
No, I'm talking about what they showed as the rocket.
Wait, hold on. I'm just gonna pull something up so we can make sure that we're agreeing with each other.
Okay.
Just so then, because otherwise we might talk past each other about what we're talking about, right?
Oh.
I'm gonna go to the
Okay.
YouTube.
Yeah, I'm just setting it now.
Oops. Let's go.
YouTube.
Well, yeah, because it was like the NASA broadcast this, and I imagine that's what you're referring to.
Oh, so you always make fun of YouTube science, but now you use YouTube.
Well, look, I watched it on YouTube because I don't have
Let's get
cable
that
TV.
Straight.
I don't have cable
Let's
TV.
get that straight. It's YouTube science then.
I don't know what you mean by YouTube science. I was just watching something on TV,
Well,
and I don't own it.
The
I don't have cable.
The definition which you claimed for YouTube science is you get your science from YouTube.
We're not talking about science. We're just talking about something that we watched together. Did you wait? How did you watch
This is all
it?
about science, Sonny. This
Wait,
is all about science.
Freddie, how did you watch it?
Yes. Where did I watch it?
Yeah.
Well, I watched it on the internet.
So like YouTube.
No.
So where on the internet?
NASA.gov.
Okay, we can go to nasa.gov. I'm sure that they still have it there.
Is that YouTube?
Yeah, they are just mirroring the YouTube live stream to their website, but
Okay, so if we went to YouTube, then would it be YouTube science?
well, we're not talking about doing science period. We're just talking about something that we watched we both
but
watched.
If
right?
I were to say go on YouTube, then you would say it's YouTube science. So I'm asking you what you would ask me. So I'm asking you if it's YouTube science then, if you go on YouTube to get your science.
No, because it's not science at all.
Okay, then.
We're just watching something. Like
Okay,
you
so
know,
the
like for
next
example,
time
Freddie.
I hear you say YouTube
So,
science,
Freddie.
I can use this against you.
So Freddie, like if I wanted to go watch some, if I wanted news on like, I don't know, a conflict in Africa, say, and I went to like, I don't know, BBC's YouTube channel, and I watched the news clip on BBC's YouTube channel, that's not science. I'm just watching something on YouTube.
Yeah,
Because
but
that's
it could be edited.
Well, yeah,
but it
I mean,
could
of
be
course,
edited.
of course. But I
Well,
mean,
of
did you watch?
course, yeah,
Did
so
you
you're
watch
not getting
the?
true thing then?
So did you watch it live? Allegedly live?
No,
the NASA the
I
launch?
actually had to work.
Okay.
I actually had to work.
I was hospitalized a week and a half ago, so I'm still in recovery mode. So I wasn't
Sorry
really
to
doing
hear
much yet. Anyway, so is this the part that you're talking about? The part that
What were you hospitalized for?
I had a pretty major surgery.
Oh, I'm sorry to hear that, buddy.
Yeah, I appreciate that. So
I hope you're doing well now.
yeah, I'm it's
I need you around to debate you.
Of course. So this is the live stream that I watched yesterday, right? And so we can.
I know you hate me, but there's no hate from me to you.
Freddie, I don't hate you. So this is the live stream that I watched. So you watched this later, I imagine. This is like the ignition, and then
there's another
they blast
cut.
off.
And then there's another cut.
Yeah.
It's
So-
a Hollywood production.
Right. So we watched this part. This part you think is real, right?
Yeah.
Okay,
so you
so-
agree it's a Hollywood production.
Well, no, it was atrociously produced, but I don't think Hollywood was
Oh,
involved.
so it wasn't a straight one cut shot. It was
Well, that doesn't mean
repeated
it's.
cuts
But that doesn't mean that it's Hollywood,
for
right?
entertainment.
So
Well,
okay,
it's
so
for entertainment.
so
purposes.
Freddie, hold on. So we agree that all of this part is real, right? The part that we're watching
Well,
right
yeah,
now.
it's like a bottle rocket. I could
Okay.
shoot a rocket from Japan in the sky, and it'll still
Okay.
go up.
So there's booster separation, right? You can see the booster
But I
separation
want-
there.
This is what I want to know.
Hold on.
That's pushing off of matter.
Freddie,
There's
Freddie,
no
before we
matter
start.
in a vacuum.
Freddie, before we start. So it goes from here, and here, this is the back
Wait a
of the
minute.
rocket.
You just asked me about the rocket, and I'm asking you a question about science.
We can, but I don't want to change topics before we.
So
I
what
don't want
are
to
you
change topics
showing me?
immediately. So this is the rocket launch that we both watched yesterday, right?
Yeah, so we
Okay.
saw it go up, and then
So,
we saw
okay.
it sideways.
So right now what we're seeing is the back of the rocket, right? That little white dot
Are you
is the back
playing
of the
a video
rocket.
game? What are you? What are you tapping so hard for?
I'm scanning left and right in the video,
Why
right?
don't you just use the cursor and move the fucking the red thing?
It's more precise this way because this is an 11-hour stream or a 10-hour stream. So that little white dot there, that's the rocket, right? That's the back of the rocket that we're seeing.
I guess.
I mean, we could just follow it. And so like, here's the rocket.
Sure.
Okay, so
Yeah. Can you prove to me there's people on it right now?
no, and we can talk. I mean, we can talk about that later. But I just want to.
All my questions
so
have
Freddie,
to wait till later until you're done tapping.
well, so, no, Freddie, I'm just trying to lay like a ground level parts that we agree on.
I'm just
right?
asking you a simple, nonsensical question.
Okay, I understand that, Freddie. I'm just trying to get a baseline where we agree.
Why does it have to wait? I just need an answer.
We can see the people inside. We could hear them talking. If your contention is just that it's made up.
Not from the camera on the outside.
No, of course not. If your contention is just that, like,
why aren't they waving to the camera so that they can prove it?
Do you think
like they did with Katy Perry's drop?
Freddie, do you think that you could see them from this far away?
Well, that's not the camera that's next to the ship, is it, that I'm talking about?
Well, so hold on. So, right. So I'm trying to get there, but you keep interrupting me. So that's the back of the rocket.
You already know what I'm talking about, so why don't you answer my question?
Well, we're getting there, but
it
I want to...
seems like you're running.
Freddie, I want to address something first. I want to address the first thing that you said.
Okay, keep tapping. Get to your addressing.
So here we have the back. Here we have the back of the rocket, and so here's the back of the rocket, and then
the front, right?
And now we get a cut. So this is the camera
Why is it never to the front? Can I ask you that?
Well, so the cameras are generally situated so that you can see part of the engine to make sure that everything's still okay.
Well, why don't they have a camera towards the front? Is it that expensive?
If you add the more stuff that you add, it means that you need more fuel to lift it, and the more stuff that you add on yeah, of course, because it's heavier, right?
Oh, so a gorilla suit and a guitar and a microphone and all the nonsense they brought up, that weighs a little bit more than a camera?
Yep. Yeah, it would.
Oh, like one of those little micro cameras that you can put in your pocket.
So there's fairing separation, by the way. So I mean, surely
bring iPhones up there.
They did.
Did they bring iPhones and tablets?
I don't.
But not a camera.
They did bring iPhones. Yeah, iPhones have cameras
Just
on them.
not a camera.
I think they brought two DSLRs.
Today, when our gas prices is high, and we're going to spend billions of dollars on some nonsensical trip around the moon. This is a joke.
So, Freddie.
What do you mean? So this is our tax dollars being wasted,
Freddie,
and you're over here agreeing with it.
Freddie, so I don't think that this is a waste. I think this is actually a fairly good use of money. But we can agree to disagree on that.
What are we accomplishing? The Fantastic Four going around the moon?
So, Freddie, I thought we were going to let each other finish sentences. So, I think this is a fairly good use of money because I think anytime that we're funding something that is either engineering or science related, I think that the long-term benefits generally outweigh any immediate spending that we end up doing. But anyway, so here's the first cut. We go from the back of the rocket, very far away, and now we cut to the camera on the rocket. Now, of course, that's a cut. You could say that maybe that makes it fake. But I think the part that you were referring to that was like, where you can see the whole rocket, and here we're seeing it from the back again, and it flips back and forth. I think the part that you were referring to is, I'm just skipping forward a bit, is this part. Is this part, right?
Yeah, what the hell is that?
Yeah, so if you just looked, it says visualization, right?
Yeah.
This isn't, nobody's claiming that this is like an actual camera view of the rocket. This is a visualization.
Well, why don't they have a visualization of the people inside waving?
Why would that be helpful? This is obviously not real. This is like this is an animation just to show you what this is an animation to show you. Look, so this is a
simulation is unmanned. This is just not a simulation.
This is just an animation.
Well, when they do a simulation on a roller coaster, don't they put fake bodies in it?
This is not a simulation. This is an animation.
Well, oh, it's an animation now. So now we're watching cartoons.
Literally, this is a visualization of the stage that it's in because we can't see it otherwise.
Oh, it can't see it, but they even had cameras aboard.
Well, you can't see the whole rocket because you would have to have another rocket next to it pointing a camera at it.
Well, exactly. So why don't they show that camera?
They did. They showed it earlier. The camera on the side, but then you can't see the whole thing.
I want to see how.
Here,
I want to see how it moves in a vacuum.
Here, you're seeing it right now.
No, that's not a vacuum.
Well, I mean, there's no true vacuum, but it's close.
Well, they're not going up. I want to see where they go up. That's the part I want to see.
But they weren't aiming up. They were trying to get into orbit, which is around, not up.
But orbit is only going around a circle, isn't it?
Yeah, not up. You're right.
Yeah,
so what a
and
rocket
circle
does
is two-dimensional and flat.
So what a rocket does is it goes up until it gets past most of the atmosphere. Freddie, I thought we were going to let each other finish sentences. So what an orbit is, the way that you get to orbit from the ground, is you go up to get past most of the atmosphere, and then you tilt over and accelerate sideways until you're going around. And so that's why they're going sideways now, because that's what an orbit is.
Hey, okay, so can I ask you to do me a favor?
Sure.
The next time they do a launch, rather than sit at Cape Canaveral and watch, why don't we all sit around, I don't know, let's say the Bermuda Triangle, and see if anything falls from the sky?
Yeah, you could if you wanted to.
Yeah, I say we do that.
Okay. I mean, like, look, the thing is you're going to make you'll make the claim that, you know, it just landed in the Bermuda Triangle, but nobody ever provides evidence that that's the case. They kind of just say it.
Well, that's because the Navy wards off everybody from that area.
Really?
Yeah, it's known.
Where's the evidence of that?
You can, it's YouTube. It's YouTube science.
Well, no, okay, so I'm asking for like some sort of historical evidence that like this is a thing that happens.
So now YouTube science isn't good enough, but it was good for Fred.
I'm not asking for science at all. I'm just asking for like evidence that this is a thing that happens.
You told me to go to YouTube, and you said it wouldn't be YouTube science. And
that's because it's not science at all.
On YouTube,
we're not doing science.
It's not science.
We're not doing science at all.
Where's the science? Well,
no, I didn't say where.
I didn't. Gas pressure required. Are you talking over me like you said you wouldn't?
I've been trying to answer you.
I'm asking you again about gas pressure requiring containment.
Yeah, we can pivot.
And you're claiming a vacuum. I'm sorry, I'm still talking.
Go ahead.
You're claiming that a vacuum allows rockets to move through, and that a rocket can go through a closed system, a closed dynamic system to be exact.
Sorry, what's the question?
So how does that work? How do you defy all laws of physics and science? I don't get this.
Which law of physics do you think I'm denying here?
How in a vacuum with no matter, how does a rocket move? What does it push off of?
So once you're already going, Newton's law of inertia states that you'll just keep going. You don't have to do anything to keep moving.
Oh, really?
Yeah, so that's Newton's first law.
Well, why do they need the thrusters on the entire time in your little diagram?
Because they're not
animation.
They're not going fast enough yet.
What do you mean they're not going fast enough?
They have to go a certain speed in order to enter an orbit, right?
Well, I've never seen rockets on Earth that can achieve those speeds.
You did just watch one, but you know.
Well, it didn't go up that fast.
I mean, I don't know if you were paying attention to how fast it was going. They had like a speed tracker, and like
a view from an airplane.
I think like 2 or 3 minutes in, it's going thousands of miles per hour.
Well, then it should have shot straight to the moon in seconds.
Well, not if the moon is 238,000 miles away.
Oh, I thought it was 289,000 miles away.
I don't know. I could be wrong. I could get the exact number for you if you want.
Oh, I don't worry. I got you the number that supposed globe.
It's 238,900 miles. That was right.
Oh, they must have changed it. It used to be 289,000 when they landed on the moon. That's what they claimed.
I don't think so. I think you may just be misremembering. But that's neither here nor there. The point is that
must be that fucking Mandela effect, huh?
Yeah, exactly. So if you want to just go through space, you need to be if you want to just go through space at a certain speed, then you just have to keep go. You don't have to do anything. You'll keep going. But if you want to change your speed,
how do you stop?
You have to turn your rocket around and fire them to stop.
How do you turn the rocket around if you're going in one direction?
You can use thrusters.
What are the thrusters pushing off of in a vacuum?
Thrusters don't have to push off of something external.
Well, you can't push off yourself. That's Newton's third law.
No, Newton's third law allows you to push off yourself, actually.
Oh, so if I'm standing on a skateboard and I push on my chest, I'll start moving?
No, you have to separate from the thing. The two things have to push off of each other, so they separate.
Push off of something.
Well, you can. So, like, I'll give you an example.
So then your rocket experiment doesn't work in a vacuum.
Freddie, so if you and your friend are both on a skateboard and you're holding hands, and then you push each other away,
Might cut him.
you and your friend
He
will
might be
push
holding
each other.
onto my wrong hand.
You and your friend can push each other away from each other, and then you'll separate and go in opposite directions.
One push off of another fucking force, off of something.
Well,
There's nothing in a vacuum. A vacuum is the devoid of matter you're trying to tell me I'm pushing off of.
Freddie, the gases.
Am I not pushing off of the friend that's matter?
Yeah, sure. There's two different things happening in a
where
rocket.
is this wall or matter thing that I'm pushing off of in a vacuum?
I'm happy to explain, Freddie. The gases in the combustion chamber push off the rocket, and the rocket pushes off the gases.
That's pushing off of yourself. That's pushing off of yourself.
No, they're two separate things. The gases have mass, and the rocket has mass.
Let's try it this way. Let's try it this way. A man standing at a wall pushes on the wall. The wall, being matter and not moving, has a force of equal pushback, right?
Yep.
Okay, so there's your force, right? Pushing and then the opposite, right?
Yeah, sure. That's Newton's third law.
So if the rocket is pushing, what's it pushing against?
The gas.
You can't push against the gas.
You can push against the gas. Sure, you can.
It dissipates in a vacuum.
Well, they carry the gas with them. That's what the combustion chamber does.
I know, and as soon as it's ejected, it's fucking dispersed, like popping a fucking helium balloon. The gas is now gone.
You're right, Freddie. You're right. The point is that it disperses. It disperses.
I'm always right. Tell all your fans.
Freddie, it disperses in a specific direction. And that's the important part.
In a specific direction.
Yeah, that's what the nozzle of the rocket engine does. It forces the gas to disperse in a specific direction, which applies a force in the other direction.
So Newton used rockets. Newton had a vacuum he flew through.
No, that seems like completely unrelated.
Okay, so Newton requires a matter to push off of, which there isn't in a vacuum. Again, you lie.
I don't know why you say Newton requires matter to push off of.
Because how does a boat move by itself without being in water? It's pushing, but it ain't moving if it ain't in water, right? Unless it's on a trailer.
So the way that a boat functions.
Dude, let's use some common sense here.
Freddie. The way that a boat operates is it takes ambient stuff and it pushes that ambient stuff away so that it goes in the opposite direction. So this is how like a propeller on a plane works.
Yeah, like an
this is
airplane
how
pushes air, right?
I thought we weren't going to interrupt each other. This is how a propeller on a plane
I'm just
plane
agreeing
works.
with you to include an airplane.
I was getting to that, Freddie. I don't want to have to mute you, but like you got to let me finish the sentence, okay? So this is how a propeller on an airplane works. This is how a propeller on a boat works. This is how propellers work. However, rockets don't operate under that principle. Rockets carry the stuff that they push away inside of them. So think of it like this. Imagine, for example, that, and I just want you to use the abstract thought here. So imagine, for example, that you're floating in space. It's a vacuum all around you. And then you take a bowling ball that was inside your rocket ship, and then you just stick it down right outside of your rocket ship. Then you reach out and you just shove it away. What happens?
Well, you're pushing off of matter.
Yeah, it's the bowling ball, right? So you would go back and the bowling ball would go forward, right?
It would have an equal force.
Yeah, so you would both go in opposite directions.
Correct.
Now, that's exactly what happens with the gas that a rocket uses. It's the exact same thing, exact same principle. The rocket carries the gas with it, and then it forces it away from it. It pushes it away.
So, let's see. If I pushed off of something stationary, then I would move, right? Like if pushing off of, say, if I was on the side of a rocket, and I push that rocket, the rocket would move at a force the same as me.
It doesn't have to be stationary, right?
Well, it's floating, it's stationary. What do you want me to say?
So sure, we can suppose that we can suppose that it's stationary, sure.
Yeah, just floating in a vacuum.
Yep.
So that's me pushing on something.
Yeah. You would both go in opposite directions.
Now let's turn me around, and I'm using my arms as the thrust, and now I'm pushing at nothing. Now, how am I moving through this vacuum?
That's the deliberate, perhaps, misunderstanding. You're not.
That is not a misunderstanding.
Rocket,
that is exactly what you're telling me with thrust.
No, you understood the bowling ball example, right? If I take a bowling ball from inside my rocket, right? The gas,
pushing off of
the thrust is the something you're pushing off of.
No, the thrust is your arms moving. That is the action.
No. So the gas.
My arms are connected to my body.
You're right.
The rocket.
Freddie,
the arms are the action, which is the thrust, the motion, the force.
Freddie, I misspoke. It's the exhausts that you're pushing off of, not the thrust. The thrust is the force. The exhaust is the thing that you're pushing off of.
There is no exhaust. In,
there
in
is.
a vacuum. There's no matter.
From a chemical propulsion.
Yeah,
there's absolutely exhaust.
In a vacuum are nothing.
What do you mean they're nothing? They don't cease to exist. What do you think happens to them?
Oh, what do they do? What do they do? They stick around.
I mean,
they like microplastics.
They
you
go.
Can't get rid of them?
They go in the direction that they go in. Whatever direction they were going in, that's the direction they go in. Whatever direction they're pushed in, they go in that direction.
Bubbles in space, those just float around too. Then.
What bubbles?
Oh, every time I see something in space, there's bubbles. Like when
this seems like a deflection.
When they showed the rocket Artemis 2 separating, you saw all those bubbles and shit.
What was that? Oh, we can. Actually, I think you're talking about this part right here. Here, let me put it up, and then just to make sure that we're talking about the same thing. You mean this part, right? Let me hit play. So here, not. It's gonna change over. You mean this part right here?
Yeah.
That's debris. It's solid matter. It's not bubbles.
Oh, debris. Okay.
Yeah. So here's a learning.
So they didn't clean it before they shot it up.
No.
They want to just put space junk in space.
Let me explain. So in order for the separation to happen, they have to explode something. They're called separation rings.
Unhook a latch.
Yeah, no, because they have to actually separate from each other. So they have something called a separation ring.
Why when they reconnect, it's just on like a valve system with a little turning thing, like for the valves.
Yeah. So when you're docking, when you have two spaceships docking, they don't need as strong a structural seal as is required during a launch.
Oh, so the seal isn't needed to be strong.
It'll be airtight, but it won't be like structurally rigid, you know.
So it's airtight to a vacuum, which needs for on Earth, how many inches thick of concrete and rebar
to make something airtight?
Little seal you're telling us about.
Wait, to make something airtight, you don't need anything that thick. You just need some plastic and some O-rings.
Oh, okay.
But if you want structural strength, then you might need exploding bolts, which is what they use here.
Exploding bolts. So
yeah.
Okay. So it doesn't implode then.
It explodes.
No, I'm saying when they dock, it doesn't implode.
Why would it implode?
Well, they're in a vacuum, of course.
Why would them being in a vacuum make them implode?
Oh, the pressure.
What pressure? A vacuum has like basically zero pressure.
Oh, okay. Zero pressure. And what's the pressure on the inside?
That's like definitionally what a vacuum is. The pressure on the inside is going to be whatever it is.
It doesn't get to a complete zero, right?
Yeah, it gets close to zero. The vacuum on the inside of the space station is like 10 psi or 8 psi or something like this.
At least I had that one right?
Yeah. So Freddie,
okay, good.
So Freddie, you now understand how you can.
I thought you were going to say I was wrong on everything. Wow,
so Freddie,
I was sweating over here.
So Freddie, you now understand how you can produce thrust while in a vacuum, right? You just have to shove something from inside of you, shove it away.
It still doesn't work with Newton.
Sure it does. This is Newton's third law in action.
No, it's actually not.
It is. For every action, there's an equal and opposite reaction. So you have the combustion chamber. Inside the combustion chamber, in the bell of the rocket nozzle, you have an explosion happening. That explosion applies a force in all directions equally. Some of that explosion applies a force to the rocket forward, and the rocket applies a force to the combustion backwards, or to the combusting gas backwards.
So, like in the movie Star Wars, when they blew up the Death Star, and you saw those big explosions happening, that would actually happen. It would. With oxygen?
You can have explosions without oxygen, yeah.
Yeah, like to show like how they did with gas bombs.
Well, I haven't seen the Star Wars movies in a long time, but I don't know.
I thought they were your favorite.
No, I'm not really into Star Wars. But my
No,
point is that you
that's
can have
surprising.
explosions. You can have explosions in
Are you
a
in the
vacuum.
Legos?
Not really.
Oh.
But look, Freddie, you've been on for 26 minutes. I hope that you learned some stuff about Newton's third law. I'm going to let you go.
Well,
But thanks for being here, Freddie.
I hope you learned that you can't push off of yourself.
Well, I never made that claim. Thanks for being here, Freddie.
Yes.
That was the most cordial I've ever gotten Freddie to be, and that's because I kind of demanded it. You just gotta kill him with kindness, right? All right, let's read some super chats and then we'll bring up our next guest. From DJ Big Lex with the $2. Earth shape is a heart from my love for you, Blitz. Oh, that's so sweet. From Joshua Everett with the $5. See, only one side of the flat sun lights up, so that's how night works. There you go. From That's Ticky Boo with the £2. Buoyancy was the best part of Destiny's Child. I feel like I'm missing a reference here. From Tim Bimbadil with the $2. Glad you're good, King. Yeah, I'm doing okay. From Deity Puddin with the $2. Mobius Strip Earth. Oh no. No, we don't want to do that. They will be confused by non-orientable spacetimes. From Binary Ghost with the $10. Freddie brings up a good point. If you can't trust the internet for some information, you probably shouldn't trust it for others. The Artemis launch was shown to me in a dream. There you go. We can trust the dreams, though. Oh, buoyancy sounds like Beyonce. I get it. I get it now. From Gretchen with the $3. Freddie doesn't do normal. I know he doesn't. But we did our best. From Garain with the $2. There's no way this is the guy's real voice. No, it's not. It's a bit that he puts on. And from Literally Lou with the 10 Australian dollars. Missed you and appreciate you. Well, I missed you guys too. All right, let us bring up our next guest. Oh, let me make sure I didn't miss anything. Any cash apps or anything like that. From Gob with the $50. I appreciate that. Sorry for sending that random TikTok to you. 'Twas an accident. I know you'll beat this diagnosis. Oh, you should go watch the most recent update I did on that, because I don't have cancer. Never did, apparently. But I appreciate it regardless. Yeah, I just wish that my I wish that my doctors had been more had been less definitive with the claim. I wish they hadn't acted as if, yep, it's definitely cancer. I wish they had been like, it seems likely that it's cancer, but we are, and so we're going to treat it as such, because that's the most dangerous outcome if it's actually cancer. I wish they had done that, but they didn't. And you know, I am not going to be too mad at them about that. But you know. Anyway, let's bring up our next guest. Like, honestly, my doctors did a great job. Gave me, took a toll on my mental health, but they did a great job. I'm not upset at them at all. All right, let's talk to Edward's Dilemma. Edward's Dilemma, how's it going?
Pretty good. How you doing?
I'm doing okay. Edward, can I call you Edward?
You can call me Edward.
Great. Edward, what shape do you think the Earth is?
The Earth is a sphere.
Okay, then why'd you join?
I think you weren't explaining to Freddie correctly the skateboard
Really?
question.
What did I say that was wrong?
Nothing, but I mean, you got to be more systematic to him. So if you're on a skateboard and you take a medicine ball that has, a decent mass and you push it away, you're going to move backwards.
Yeah.
We're apart from the medicine ball as you push it away. But if you take something like a volleyball or a play ball and you push it away with less mass, you're not going to move as much.
I don't think he didn't even understand the first part, let alone the second part. The relative mass ratio he was not there yet.
And you get a relative mass from the ejection of propellant out of a rocket.
Because he wasn't there yet.
Yeah, Newton. I'm not Newton's law, but thermodynamics. Energy is not created, destroyed. It's converted in a rocket engine.
Oh, this doesn't really have anything to do with thermodynamics.
Well,
it's not really related.
So but I think he's not thinking that the propellant from a rocket is actually matter.
I know he doesn't. It's
still matter, and if you accelerate that matter out, then that's what the engine does. It takes that fuel, solid or liquid, and it makes it more energetic.
Take it up with him. He doesn't understand that.
Yeah, he doesn't.
Thanks for being here, Edward. Yeah, I mean, you can go talk to Freddy if you want. That wasn't Freddy, by the way, because he was in the guest box while I was talking to Freddy. And unless maybe he has two phones, maybe then it was, but all right, let me just double check. Yeah, you could have two phones or a phone and a PC. Although I don't know, can you join live streams from PCs now? Maybe you can. Anyway, so currently the guest box is empty. If there are any of y'all who think that the Earth is flat or are skeptical of the globe and you want to come up and have a conversation about it, we can do that. Alternatively, you could just stay in the comments like little bitty babies, which I totally understand. I wouldn't want to debate me on the facts of the matter either. Because that would be hard. That would be hard for you guys. But, you know, if you can't do it, you can't do it, and I'm not going to fault you for it. If you don't want to join on TikTok, or if you don't have the permissions, you can just join via the Discord link that's somewhere up here. That will also get you there. I can pull you in, and then we can have a conversation about it. Yeah, but I imagine that maybe they're just not here because they're all coping because the Artemis launch. That's true. They have been taking a beating for the last 24 hours. They all have been they've been having a hard time, right, since the Artemis launch. By the way, my voice is kind of hoarse. It's kind of weak right now because for the same reason that I have this thing on my nose, because this NG tube was basically irritating my vocal cords for 72 hours or so. So that's why I sound this way. I sound softer today. But we have a guest. Let's talk to Mark. Mark, how's it going?
Hey, what's up?
I'm doing okay. Mark, what shape do you think the Earth is?
Okay, so again, I think the world is round. It's a globe. But explain to me like I'm 5. I still do not understand the concept of vacuum, bro, and a rocket propelling itself, turning itself around. Like Freddy, I'm so lost there since I was like, I actually did physics here, A level. I did the math, I did everything, but the physical logic of how something can move, like he was trying to explain. Yeah, what's up with that? Explain to me like I'm 5, bro.
So look, imagine you're floating in space, right? And you're carrying a bowling ball. What happens if you throw the bowling ball?
I'm assuming the ball will go further than me. I'll move back, and the bowling ball will move further ahead.
Great. That's thrust. You figured out thrust in a vacuum.
Am I the one who's thrusting the ball, or since like
the bowling ball is the exhaust. The thrust is a force. The thrust is the force that the bowling ball applies to you.
Okay.
It's the reason why you go backwards.
Okay.
And if you want to figure out how to turn, if you want to figure out how to rotate, all you have to do is you just have to throw something off center. So throw something with your right hand or throw something with your left hand, and then you'll spin in the opposite direction.
Right.
That's it. It's the whole thing.
Now to the rockets.
That's what rockets do too. They just throw hot gas.
Okay.
That's it. It's the exact same phenomenon.
Thank you.
All right, I'm going to let you go, Mark, but thanks for being here. Yeah, I mean, there's a few different ways. There's a few different ways to explain this. I used to have a drawing that I used on the regular, and I'll pull it up for you. So the most accurate way to represent what's going on in a rocket is actually not throwing a bowling ball, but the physics is the same as throwing a bowling ball. It's just not as accurate. So let me show you a drawing. Okay, so here we're going to have I'll do my best to just draw a rocket. So here's the back of the rocket, right? And it's extending off the screen. And then we're going to have have an engine nozzle, which we're just going to erase the back half. Right, so there's our engine nozzle. So what happens is that, you know, you put a little gap there, and you throw some gas into the back, right? Let's make it orange, I don't know. Actually, let's throw a little gas into the back. And this happens very, very quickly, by the way. You throw a little gas into the back, and then you light it on fire. Now, you're also going to have to probably throw some oxygen in the back as well, because, you know, there's no oxygen out there. But you basically throw gas, or really what happens in a rocket is that you often use liquid fuel. So you toss out some liquid in the back, you toss out some liquid oxygen and some liquid fuel. You throw them out, and then you basically use a spark. You heat it up really, really quickly so that it explodes. It's basically just an explosion that happens inside the nozzle. It's not quite this, but it's very, very quickly. It's very, very close. So now this explodes, and like all explosions, you have stuff that, and I'm going to draw it in orange, you have stuff that goes in all directions. Right? Stuff goes in all directions. Now, the stuff that lands here, the stuff that connects with the rocket here and the stuff that connects with the rocket there, they're going to bump into the rocket, but in opposite directions. And so those two forces will cancel out. It won't push it left, it won't push it right, because they're going to push in equal strength in both directions, right? Now, the stuff that hits the rocket here and the stuff that hits the rocket here, their left and right forces are going to cancel out, but they are both pushing on the rocket in the forward direction a little bit. So they're going to bump into the rocket going forward. They're going to push the rocket forward. And then the stuff that hits here, like, obviously there's some backflow, and so you have to do some engineering to prevent that. But the point is that you'll have a whole bunch of rocket exhaust. You have a whole bunch of rocket exhaust that ends up hitting basically the back of the rocket, pushing it forward. And the rocket exhaust that would normally cancel it out if this was happening, in an enclosed sphere, that stuff goes out the back. And so even though the total momentum of the explosion is 0, meaning that it shoots out stuff in all directions equally, some of that stuff pushes the rocket forward and the rest goes out the back. That's basically what's happening. That's why the rocket goes forward. The rocket doesn't literally throw stuff out the back, right? It's not like it doesn't have an arm that it's using to chuck stuff out the back. Obviously, this is also oversimplified, but this is the idea. So it's the exhaust pushing the rocket forward and the exhaust pushing the rocket, or it's the expansion of the exhaust in all directions that both pushes the rocket forward and then it bounces off and heads backwards and goes out the back end. That's what's happening here. From Brienne Doherty with the $5, I gotta argue with the FLERF tonight. He thinks Boyle's law disproves gravity. Boyle's law, is that the one about pressure being related to temperature? I can never remember any of these because they're all just like results of the ideal gas law. Okay, Boyle's law is that pressure is inversely proportional to volume. Okay, so this is, yeah, okay, so if the temperature and the amount of gas remain unchanged within a closed system, then the pressure exerted by a given mass of an ideal gas is inversely proportional to the volume. I don't see how this is going to have anything to do with gravity. The whole point is that our Earth is not a closed system, right? Like, it's just not. The temperature of the air is not fixed, so I don't know where they're going to go with that. From Reverend Nate with the 5 Canuck bucks, why do so many adults think rockets are constantly using propulsion systems in orbit? Too many Marvin the Martian cartoons, I guess. Yeah, it's that, and that we're used to thinking of things requiring constant thrust in order to keep going on Earth because we have drag, right? You have to keep your foot on the pedal to keep going, just because there's friction and drag slowing you down the whole time. And from Necta with the $10, glad you're back, boss. Let's go. Indeed, let's go. Currently, there's nobody in the guest box though. I mean, we could end the live a little bit early. You know, as a first day back, we don't have to overdo it, but I do feel fine. I feel fine to be sitting here, but there's just nobody in the guest box. So it doesn't sound like any flat earthers actually want to have a cordial, educated discussion about this, right? And from Dr. Fudge with the $10. Happy about the news doc. Saw the kitty earlier. That was nice. Yeah, the kitty is nice. She's a good girl. She's also horrible, but from Chrissy with the $2. If you fart in space, does it propel you forward? Yeah, it does. It absolutely does. And from Game Master Flash with the $20. Blitz, welcome back. Hope you're doing well and recovering. I am recovering. There have been some hitches along the way, but we're working on it. Yesterday's launch taught me that humans are amazing when we aren't being fucking idiots. Yeah, that's true. I'm with you on that. Yeah, it is spectacular to see that. I can't wait till we get to see them go around the moon. That's going to be something else to watch, but that's not for a few days if I remember correctly. All right, let me just double check one more thing, and then we might just call it a day then. No use in overexerting myself anyway. So, guys, I will be back tomorrow for some religion debate, the kind of normal stuff that we would do. I'm happy to talk to anybody tomorrow, but we're going to call it a day today. We'll go a little bit longer tomorrow as well. So if you haven't already, if you want to get announcements about when I'll be live tomorrow, make sure to join the Discord. Go to discord.gg/drblitz. It's a great way to get announcements about when I'm live, about my health updates, about when I post videos and things like that. It's also a great way to talk to like-minded people. And if you haven't already, make sure to also subscribe to my debate YouTube channel at Dr. Blitz Debunks. It's a great way to support me if you don't want to contribute financially, which you're not obligated to do. Just subscribe. It won't hurt anybody. All right, I will see you guys tomorrow. I'm going to go loaf on the couch for a while, I think.